Did you know that somewhere out there, right now, an entire universe might be quietly beginning to form, hidden just beyond the edge of everything we can see? Stay with me tonight, because by the time you drift off, you will never look at the night sky the same way again. Hello there, and welcome to this quiet place, a place where curious minds can come to rest. If you've had a long day, or if you simply enjoy drifting off while thinking about the universe, I'm glad you found your way here. Because tonight's journey is just for you. A slow and gentle wander through the vastness of the cosmos. There's nothing you need to do now, but relax. Let your breathing slow down, and allow your thoughts to soften. Tonight, we'll slowly explore some of the most fascinating mysteries of our universe, letting each fact and each curiosity settle like moonlight on calm water. Some of what you hear may feel familiar, like the steady glow of ancient stars. Other moments may surprise you, like rogue planets drifting without suns, or black holes bending the very fabric of reality. If these quiet explorations help you rest, feel free to like and subscribe, or share a thought below. It helps others find their way here as well, one sleepy soul at a time. But for now, simply settle in. Let the calm of the cosmos surround you. Let the busy day fade away. And if you're ready, let's begin. We might one day watch the birth of a new universe. Though our universe feels complete, some theories suggest that new universes may still form, sprouting from quantum fluctuations or budding off from black holes. If so, the birth of a new universe may one day be something we can glimpse, though never enter. It would appear as a bubble of space-time forming and expanding, disconnected from our own. To us, it might be only a flash, a brief distortion, gone before we could understand. But within that bubble, an entire cosmos could unfold, with its own stars, its own galaxies, and perhaps its own forms of life. The idea is dizzying, that new realities may be blooming even now, unseen beyond our reach. If true, then creation never truly ends. It is always beginning again, universes growing out of universes, a cosmic garden with no final boundary, no final horizon. The cosmos is still ringing from its earliest moments. When the universe was born, it was filled with ripples of energy, vibrations in spacetime itself. These primordial waves still echo faintly across the cosmos, etched into the background radiation, and perhaps still rippling invisibly through space. Astronomers call this the cosmic ringing, the aftershocks of creation, frozen into the fabric of reality. With sensitive instruments, we can trace these patterns, learning about the very first moments of the universe, when physics itself was still settling into form. To imagine it is to hear a faint, endless the universe singing softly from its own beginning. Long after the first light faded, these echoes remain, telling a story billions of years old. They are reminders that the universe is memory, that every vibration, every ripple, leaves a trace. Creation itself still resonates quietly in the silence of the night sky. The oldest light we can see comes from 380,000 years after the Big Bang. Before that moment, the universe was a glowing fog, so hot and dense that light couldn't travel far without scattering. But as it expanded and cooled, it reached a turning point. Atoms formed, the fog cleared, and light was suddenly free to move. That ancient light is the cosmic microwave background, and we can still detect it today. It's the oldest direct signal in the universe, not from stars or galaxies, but from the universe itself, when it was just beginning to become transparent. The photons we observe now have been traveling for more than 13 billion years, stretched by the expansion of space into long, cool microwaves. This light is faint, but ever-present, a quiet glow that carries the memory of the universe's earliest clarity. Some stars have planets made almost entirely of diamond. In certain solar systems, the chemistry is very different from ours. If a planet forms with more carbon than oxygen, and the pressures are high enough, something remarkable can happen. A diamond planet. Astronomers have discovered at least one such candidate, a dense world orbiting a pulsar, likely the remnant of a dead star. Based on its mass, density, and composition, the entire planet may be a crystalline form of carbon, essentially a giant diamond. It's far too hot to sparkle, and it wouldn't look like a jewel up close. But deep beneath the surface, immense carbon lattices could stretch for thousands of kilometers. These strange worlds aren't common, but they remind us how diverse the universe can be. A planet made of rock, a planet made of gas, and sometimes, a planet made of crystal. The universe may have no edge, just endless curvature. It's tempting to imagine the universe as something with an edge, a border we could reach if we traveled far enough. But space doesn't seem to work that way. According to general relativity, the shape of space is determined by its contents, and current evidence suggests that the universe is either infinite or so vast and curved that it loops back on itself. If that's true, you could, in theory, travel in a straight line forever, and eventually return to where you started, not by hitting a wall, but by wrapping around curved space. This is similar to how traveling around Earth doesn't reveal an edge, just a globe. The universe may work in the same way, on a much grander scale. Not infinite in space, but infinite in journey. The universe is vast, and you are a way for it to know itself. For all its galaxies, stars, and mysteries, the universe would be silent without eyes to see and minds to wonder. Through us, through life, thought, and curiosity, the cosmos reflects upon itself. Every question asked, every star admired, is the universe becoming aware of its own grandeur. You are made of its atoms, shaped by its stars, carried by its history. In you, the vast reaches of time and space have found a voice, a perspective, a fleeting spark of consciousness. To rest beneath the night sky is to realize that you and the stars are not separate, but parts of the same whole. The universe is vast beyond imagining, yet in you, it has found a way to wonder at its own existence. That is perhaps the greatest wonder of all. Some stars are stripped down to bare cores of pure carbon. Stars come in many forms, and some live such unusual lives that they end as something rare and strange. These are white dwarfs, made almost entirely of carbon, stripped of their outer layers until only their dense, crystalline cores remain. In essence, they are stars that have become giant cosmic diamonds, glowing faintly as they cool. Over billions of years, they will crystallize fully, their interiors hardening into lattices of pure carbon. Though they no longer shine as brightly as their former selves, they are treasures of the cosmos, brilliant in concept, if not in light. To imagine them scattered across the galaxy is to picture hidden jewels drifting silently among the stars. Each one is the remnant of a lifelong past, a shining ember turned into a gem, proof that even in death, stars can become beautiful in new ways. Most of the universe's history hasn't happened yet. Though the cosmos feels ancient at more than 13 billion years old, this may only be its beginning. Stars, galaxies, and even black holes will continue to exist for trillions upon trillions of years to come. In fact, the era we live in, when stars are still shining, when galaxies are bright, may be just the opening chapter of an unimaginably long story. The majority of the universe's history lies ahead, in epochs we cannot truly fathom. There will be times of fading starlight, of cooling embers, of black holes slowly evaporating, and of silence stretching into infinity. To the present feels vast, but it is only a fleeting moment in the life of the cosmos. We live in a universe that is still young. Its greatest age is yet to unfold. Its longest dreams still waiting to be dreamed. Supernova remnants keep expanding for thousands of years. When a massive star explodes as a supernova, the brilliance fades within weeks or months. But the remains of the explosion, shells of gas and dust, continue expanding for thousands of years. These remnants grow into vast clouds, glowing faintly with the energy of the blast. One of the most famous is the Crab Nebula, born from a supernova observed on Earth nearly 1,000 years ago. It is still expanding, still spreading its filaments of light across space. These remnants are not only beautiful, they are the forgers of new creation, scattering elements that will someday form stars, planets, and life. To see one is to glimpse the echo of violence, softened into delicate shapes of color and light. They are cosmic afterimages, reminders that even in endings, the universe leaves behind traces of wonder that linger for ages. The sun once had a twin, and it may still be out there. Some astronomers believe that our sun was born with a twin, a companion star formed from the same cloud of gas and dust over 4.5 billion years ago. Many stars form in pairs, and there's no reason to think our sun was an exception. If it existed, this lost sibling would have drifted away long ago, pulled apart by the slow gravitational tug of the Milky Way. It might still be out there, orbiting the galaxy on a different path, invisible to us now. Some theories even link this twin, nicknamed Nemesis, to mysterious extinction patterns on Earth, though there's no solid evidence for that. Still, the idea lingers. But our sun, steady and alone in our sky, may once have shared its birth with a silent partner, long vanished into the stars. A raindrop of neutron star would weigh more than Mount Everest. Neutron stars are the collapsed cores of massive stars, incredibly dense remnants left behind after supernova explosions. They're only about 20 kilometers wide, but their mass is greater than the sun's. The matter inside is so densely packed that a single teaspoon of it would weigh billions of tons. If you imagined a single raindrop of neutron star material, it would be heavier than any mountain on Earth. That kind of density defies our everyday experience. Atoms are crushed together so tightly that electrons and protons merge into neutrons, forming a kind of superfluid neutron soup. Neutron stars are extreme objects, small, dark, heavy, and spinning rapidly. But in their quiet mass, they hold the memory of stellar collapse, a final state where matter becomes nearly pure gravity. Light from one galaxy can reach us from multiple directions. Sometimes, light doesn't travel in a straight line. In regions of space where gravity is especially strong, near massive clusters of galaxies, for example, spacetime itself curves. This curvature bends the path of light, like glass bending a beam. It's called gravitational lensing, and one of its strangest effects is that we can sometimes see multiple versions of the same distant galaxy from different angles. These images can appear as arcs, smudges, or even complete rings. They're not duplicates in space, but duplicates in vision, different paths that light has taken through warped spacetime to reach our eyes. In a few rare cases, astronomers have observed the same supernova explode more than once, as its light arrived through different gravitational routes. It's a quiet reminder that in the universe, even light can get lost, take a longer path, and still find its way home. The first stars may have burned 1,000,000 times brighter than the sun. The very first stars were unlike anything we see today. Born from the pure hydrogen and helium left after the Big Bang, these stars, called population 3 stars, likely formed with no metals at all, making them massive, hot, and short-lived. Some may have been hundreds of times the mass of the sun. They would have burned through their fuel quickly, shining 1,000,000 times brighter than our own star, then collapsing in spectacular explosions after just a few million years. None of these stars survive today, but their brief lives changed the universe. They created the first heavy elements, seeded galaxies with light, and set the stage for everything that followed, including us. Their light is gone now, but their fingerprints remain in the chemistry of ancient gas clouds, and in the quiet structure of the early cosmos. Dark matter streams through your body as you sleep. As you lie still, dark matter flows silently around you. It's not some invisible mist, it's a form of matter that doesn't interact with light, doesn't reflect, emit, or absorb it. But it has mass, and it responds to gravity. Our galaxy is surrounded by a vast halo of dark matter, and as Earth moves through this halo, trillions of dark matter particles are thought to pass through every square centimeter of your body each second. They don't collide with your atoms. They don't leave a trace. But they're there, ghost-like, ever-present, and essential. Without dark matter, galaxies wouldn't hold together, cosmic structures wouldn't form, and the universe would be very different. We still don't know what dark matter is made of, but we know this much: it's part of your world, passing through you, silently and continuously, even as you sleep. Some galaxies glow without any stars inside. In the quiet reaches of the universe, astronomers have discovered galaxies that shine, but barely contain any stars. These ghostly systems are full of gas and dark matter, but show little to no evidence of star formation. Some may have lost their stars in violent gravitational encounters. Others may never have made many stars at all. A few are nearly invisible except in certain wavelengths of light, faint smudges in deep surveys of the sky. These galaxies challenge what we thought we knew about how galaxies form and evolve. If they're rich in dark matter, why haven't they built stars? If they had stars once, where did they go? These dim, quiet systems float through space like forgotten bones of cosmic history, reminders that not every galaxy is filled with blazing light. Some simply drift, unseen and unanswered. The universe has a cold spot that shouldn't exist. In the cosmic microwave background, the faint glow left over from the Big Bang is a patch of sky that's unusually cold. It's not just a little cooler than its surroundings, it's significantly colder and much larger than scientists expected. This cold spot spans hundreds of millions of light years, and its presence doesn't quite match the smooth randomness we'd expect from early universe physics. Some think it may be the imprint of a vast cosmic void. Others wonder if it could hint at something even stranger, like the collision of our universe with another in the very early moments of inflation. No explanation so far fully fits. The cold spot remains one of the most quietly unsettling puzzles in cosmology, not a screaming anomaly, but a whisper that something about our universe may not be what it seems. The moon is slowly leaving us behind. Every year, the moon drifts a tiny bit farther away from Earth, about 3.5 centimeters. That's roughly the rate at which your fingernails grow. This slow retreat has been happening since the moon formed, around 4.5 billion years ago. Back then, it was much closer, and a day on Earth was just a few hours long. The cause is tidal friction. As the moon pulls on Earth's oceans and Earth spins beneath them, a small transfer of energy gradually pushes the moon outward in its orbit. It's a quiet, relentless process, invisible on human timescales, but unmistakable over eons. In the far future, Earth and the moon may become tidally locked, always showing the same face to each other. For now, it just keeps slipping away, little by little, as we spin beneath its distant glowing light. Binary stars can swap their outer layers like dancers in contact. In some binary star systems, the two stars orbit so closely that their outer layers begin to touch. As they evolve, one star can swell and spill matter onto the other, creating a delicate spiraling exchange of material. Sometimes the transfer is calm and steady. Other times it triggers bursts of light, rapid rotation, or even a complete merger. The physics is complex, but the image is oddly graceful. Two stars locked in orbit, spinning close enough to brush and blend. One star may end up stripped to a glowing core, while the other becomes swollen and enriched. Their fates are bound together. Some of the most unusual objects in the universe, like certain supernova or compact neutron star pairs, begin as these quiet touching binaries. A reminder that in space, even stars can share, change, and sometimes embrace. The vacuum of space is not truly empty. Even in the deepest, darkest reaches of space, far from any star or galaxy, the universe is never truly empty. According to quantum physics, what we call vacuum is a sea of activity. Tiny particle-antiparticle pairs blink into existence and vanish almost immediately. These quantum fluctuations happen all the time, everywhere, creating a kind of restless background to reality itself. They can influence the motion of particles, affect the behavior of fields, and even contribute to the energy of empty space. This is part of what gives rise to dark energy, the mysterious force accelerating the expansion of the universe. So, when we picture deep space as silent and still, that image is only partly true. Beneath the quiet lies a dance of probabilities, a hidden hum of creation and disappearance, always just below the surface of nothing. Time may flow at different rates in different regions of the cosmos. We think of time as steady, a ticking rhythm that flows the same for everyone, everywhere. But in reality, time is deeply linked to gravity, motion, and the shape of spacetime itself. In regions where gravity is strong, like near a black hole or a dense galaxy cluster, time slows down relative to places where gravity is weaker. This isn't just theory, it's been confirmed by experiments, satellites, and atomic clocks. But some cosmologists wonder whether time could also vary on even larger scales. Could different parts of the universe experience time at slightly different rates due to how the universe expanded in its early moments? The idea is speculative, but it opens strange possibilities. In a cosmos governed by relativity, even time may not be absolute. It may stretch, slow, or bend, quietly shaped by the space through which it flows. The Milky Way has a hidden halo that's larger than the visible galaxy. When we look at images of the Milky Way, we see a glowing spiral, stars, dust, and gas arranged in beautiful arms. But surrounding this familiar structure is something vast and mostly invisible, the galactic halo. It's a huge sphere of diffuse gas and dark matter that extends far beyond the visible edge of the galaxy, reaching distances many times greater than the span of the disk itself. This halo contains ancient star clusters, stray stars, and vast amounts of unseen mass. It's held together by gravity, shaped by the history of collisions and mergers, and plays a quiet role in the galaxy's stability. Though we can't see it directly, we infer its presence through the motion of stars and the bending of light. The Milky Way, it turns out, is just the bright center of something much larger, a glowing heart wrapped in invisible arms. We've detected light from a galaxy just 200 million years after the Big Bang. The universe is about 13.8 billion years old, but light doesn't travel instantly. It moves through expanding space, stretched and slowed along the way. That's why we can see galaxies not as they are, but as they were long ago. Recently, astronomers using the James Webb Space Telescope identified light from a galaxy that existed just 200 million years after the Big Bang, a blink of time on the cosmic scale. That light has been traveling toward us for more than 13.5 billion years. The galaxy itself is small, faint, and primitive, but it holds clues to how the first structures formed. Observing it is like looking through a narrow window into a world we were never meant to see. The universe in its earliest chapters, when darkness was just beginning to give way to stars. The large-scale structure of the universe looks like a neural network. When astronomers map the positions of galaxies across enormous distances, a surprising pattern emerges. Galaxies aren't scattered randomly. Instead, they cluster together along long, thread-like filaments with vast, empty regions, cosmic voids, in between. This interconnected web stretches across billions of light-years and is sometimes called the cosmic web. What's eerie is that when you zoom out far enough, this structure looks uncannily like a neural network, the kind found in the human brain. Dense nodes of galaxies are like neurons, and the filaments are like axons connecting them. Of course, the resemblance is purely structural. The universe isn't thinking. But it's still quietly beautiful to consider the largest structure we know and the one inside your own mind, shaped by entirely different physics, can end up looking so strangely alike. Stars can sing through the vacuum of space. There's no air in space, so we don't hear sound the way we do on Earth. But stars still make sound, deep, slow vibrations that travel through their interior gases like seismic waves through a planet. These pressure waves make the star pulse and oscillate, and scientists can detect them by observing tiny changes in the star's brightness or surface motion. The field that studies this is called astroseismology, literally, the seismology of stars. Each star has its own frequencies, like a fingerprint, determined by its size, structure, and age. By listening to these stellar vibrations, scientists can peer inside stars and learn what's happening beneath the surface. It's a kind of cosmic echolocation, a way to hear the music of stars across light years, even if the song is silent to human ears. Some stars are older than the galaxies they live in. Galaxies are not built all at once. They form over time, merging with smaller systems and drawing in stars and gas from other regions. That means some stars inside a galaxy can be older than the galaxy's current structure. They may have formed in earlier, smaller galaxies that later merged into a larger one. These ancient stars often live in the outskirts or in globular clusters, tightly bound groups that orbit far from the galaxy's core. Some of them are over 13 billion years old, nearly as old as the universe itself. They carry the chemical signature of a much younger cosmos, when there were fewer heavy elements and only the simplest atoms. These stars are like fossils, quiet survivors from before the galaxy fully came together. Their light is old. Their stories began before much of what we know had even formed. There are galaxies without dark matter, and we don't know why. Dark matter is thought to be the invisible glue holding galaxies together. It explains why stars in the outer regions of galaxies move faster than expected, and why galaxies cluster the way they do. But in the last few years, astronomers have found galaxies that seem to defy this rule, galaxies that behave as if they have no dark matter at all. The stars move as though only the visible matter is present. This discovery was unexpected, and it doesn't fit easily into current models. Some scientists think the dark matter was stripped away during past collisions. Others wonder if we still don't fully understand what dark matter is. By the way, these strange galaxies suggest that the universe still has secrets, and that the things we think are universal may not be so universal after all. The sun rings like a giant booming bell. Deep inside the sun, sound waves ripple through the plasma, bouncing from one layer to another and setting the entire star into subtle continuous vibration. These waves aren't like the sounds we hear with our ears. They're pressure waves, low, slow, and far below human hearing. But with sensitive instruments, scientists can detect them and use them to study the sun's internal structure. This field is called aleoseismology. By observing how the sun rings, scientists can map what's happening deep below the surface, its density, rotation, and even its hidden flows of hot gas. The sun, in this sense, acts like a musical instrument, vast, complex, and always playing. We just need the right tools to listen. And what we hear helps us understand not only the sun itself, but stars everywhere. Galaxies follow filaments made of something we cannot see. The universe's largest structures aren't made of stars or gas. They're shaped by something invisible, dark matter. Over billions of years, this dark matter formed enormous filaments stretching across space, and galaxies tend to form and move along these filaments like beads on a string. We can't see the filaments directly, but we can infer them by observing how galaxies cluster and how light bends as it passes through these regions. The filaments can span hundreds of millions of light-years and connect vast clusters of galaxies. In between lie great voids, nearly empty regions where very little matter exists. The dark matter filaments act like a hidden scaffolding for the visible universe, shaping how galaxies grow and where they go. And yet, we still don't know what dark matter is. The structure is there, immense, unseen, and quietly holding the universe together. Space can stretch faster than the speed of light. In normal circumstances, nothing can move faster than light, but space itself isn't bound by that rule. During the early moments after the Big Bang, space expanded so rapidly that regions of the universe were pulled apart faster than light could travel between them. This wasn't motion through space, it was the expansion of space itself. Even today, distant galaxies aren't racing away because they're moving quickly through space. They're receding because the space between us and them is stretching. And if they're far enough away, that stretching makes them recede faster than light, which is why we'll never see them again. It's not a violation of physics, but a quiet consequence of how space behaves on cosmic scales. The universe doesn't need to rush. It simply expands calmly and relentlessly beyond what we can follow. Our solar system moves through space like a helical spiral. It's easy to picture the planets orbiting the sun in neat, flat circles, but zoom out further and something stranger emerges. The sun itself is moving, orbiting the center of the Milky Way at nearly 1,000,000 kilometers per hour. As it moves, the planets follow in tow, not just circling the sun, but spiraling through space behind it. The combined motion creates a helical pattern, like a corkscrew or a twisting ribbon. Everything is in motion: the planets, the sun, the stars, the galaxy itself. There is no stillness in space, only graceful, ceaseless drift. Even as we sleep, we are tracing slow spirals through a galaxy in motion, wrapped in layers of orbits within orbits, a dance so vast we never feel it. Even nothing has a temperature. If you travel far enough from stars, planets, and galaxies into deep intergalactic space, you'll find yourself surrounded by what seems like pure emptiness. But even the vacuum has a temperature. That temperature is about 2.7 Kelvin, just a few degrees above absolute zero. It comes from the cosmic microwave background, the leftover glow from the Big Bang, now stretched and cooled by billions of years of cosmic expansion. This faint radiation fills the entire universe. No matter where you go, it's there. It's the quiet thermal signature of the early universe still lingering, still measurable. And in the future, it will cool even further. In a few trillion years, the universe may approach absolute zero, but never quite reach it. Because even in the vastest emptiness, the echo of heat remains. Quantum fluctuations may have shaped the entire universe. At the smallest scales of reality, far smaller than atoms, the universe behaves unpredictably. Tiny, random fluctuations in energy can appear and vanish in an instant due to the uncertainty built into quantum physics. And according to many cosmologists, those brief, random blips may have been magnified during the universe's first moments through a process called inflation. As space expanded at unimaginable speed, tiny fluctuations were stretched to cosmic proportions. Those fluctuations became the seeds of structure, the places where matter would clump, where galaxies would form, where stars would eventually ignite. In other words, the grand structure of the cosmos, the galaxies, the filaments, the voids, may all trace back to fleeting random events at the smallest possible scale. Everything we see today born from the trembling of nothing. Dying stars can pulse like heartbeats across millions of years. Not all stars end with a bang. Some fade more slowly, and during their final stages, they can pulsate, swelling and shrinking in rhythmic cycles. These stars, called variable stars, change in brightness over time. In some cases, the changes are steady and regular, repeating like a slow heartbeat. The pulses are caused by changes in the star's outer layers, gases expanding and cooling, then collapsing and heating up again. Some stars pulse every few days. Others take months or even years to complete a cycle. These rhythmic stars have been used to measure distances in space since their pulsation patterns relate to their true brightness. They also serve as quiet reminders that even in death, stars can keep time, not with a clock, but with a long, slow breath across cosmic ages. Earth is inside a giant bubble of hot gas. If you could see far into the invisible wavelengths of light, past what your eyes can detect, you'd find that our solar system sits inside a vast, glowing bubble of hot gas. It's called the local bubble, and it stretches for hundreds of light years in every direction. This bubble is thought to have been carved out by ancient supernova, exploding stars that blasted shockwaves into the surrounding gas, heating and clearing it out. Now, our solar system drifts quietly through this low-density region, surrounded by a shell of hotter gas and dust. It's not dangerous. It's not something we can feel, but it's there, a kind of quiet chamber around us, born from violence long ago, now part of the gentle backdrop of our galactic neighborhood. there's a vast, empty region behind the Great Attractor. The Great Attractor is a mysterious gravitational anomaly, a region of space so massive that entire galaxy clusters, including our own Milky Way, are slowly drifting toward it. But behind this immense concentration of matter lies something even stranger, a region known as the Dipole Repeller, where space appears unusually empty. It's not just a patch with fewer galaxies, it's a vast cosmic void, stretching for hundreds of millions of light-years. And oddly enough, its emptiness seems to push galaxies away. Together, the Great Attractor and the Dipole Repeller create a quiet gravitational tug-of-war that helps shape the motion of our local universe. We are drawn forward by unseen mass and pushed back by the emptiness beyond. It's a reminder that in the cosmos, both presence and absence can shape the path we follow. Neutrinos pass silently through the Earth and through you. Right now, trillions of particles called neutrinos are passing through your body, and you'll never feel them. Neutrinos are incredibly light, neutral particles produced in enormous numbers by the Sun, exploding stars, and even the early universe itself. They barely interact with normal matter. They can fly straight through a planet or your entire body without leaving a trace. Some pass through detectors buried deep underground, where rare collisions help us study them. But most simply pass through unnoticed. These particles are everywhere, all the time, silently streaming through space and matter alike. They move at nearly the speed of light, and yet they almost never touch anything. The universe is full of motion, even when everything feels still. The most massive stars can collapse directly into black holes without a bang. We often imagine the death of a massive star as a violent supernova, a brilliant explosion lighting up the galaxy. But for the most massive stars, the end can be strangely quiet. Some stars are so heavy that when they run out of fuel, their cores collapse inward, and gravity wins so completely, so suddenly, that even the outer layers fall straight in.
No explosión. No bricht farewell.
Just a sudden disappearance. This process is called a direct collapse. In a moment, a star is gone, replaced by a black hole, silent, invisible, and crushingly dense. Astronomers have even observed stars that seem to vanish without a trace, as if the light simply blinked out. It's a reminder that not all cosmic are fireworks. Some are whispers into the dark. Galaxies can orbit one another like moons around planets. We tend to think of galaxies as isolated islands in space, but many live in small groups, where they interact and even orbit one another. Our own Milky Way, for example, has dozens of smaller satellite galaxies. The Large and Small Magellanic Clouds are the most famous. These companions move around the Milky Way like moons around a planet, slowly tracing long elliptical paths through space. Sometimes, larger galaxies pull stars from their companions, falling streams, and tidal tails that stretch across millions of light-years. Over time, a smaller galaxy may be absorbed completely. These cosmic dances happen over billions of years, slow, graceful interactions on a scale we can barely imagine. In the quiet of deep space, even galaxies can keep each other company. The universe's brightest explosions come from collapsing magnetic stars. There's a rare kind of explosion called a magnetar hypernova, and it may be one of the brightest things the universe can produce. A magnetar is a neutron star with an unimaginably strong magnetic field, trillions of times stronger than Earth's. If a massive star collapses into a magnetar and releases its energy quickly, it can produce a burst of light and energy far more powerful than a typical supernova. These events may be responsible for some long-duration gamma-ray bursts, flashes of high-energy light that travel across the universe and briefly outshine entire galaxies. The explosion lasts only seconds, but its light can reach us from billions of light-years away. It's one of the universe's most intense phenomena, created by a small, dense object wrapped in magnetic fire, collapsing in on itself. The edge of the observable universe is not the edge of the universe. When we look out into space, there's a limit to how far we can see, about 46 billion light-years in any direction. That's the edge of the observable universe. It's not a wall or a boundary, just the furthest distance light has had time to reach us since the Big Bang, given the expansion of space. Beyond that, the universe likely continues. We just can't see it yet. And because the expansion of space is accelerating, some parts of the universe are moving away from us faster than light. That means their light will never reach us, not even in infinite time. The observable universe is like a bubble of vision, not the full size of reality, but just the part available to us. Beyond that, more galaxies, more stars, maybe forever. Some galaxies shoot jets of plasma for millions of light-years. At the heart of many galaxies lies a supermassive black hole. And sometimes, as matter falls toward it, not all of that matter disappears. Some of it gets caught in magnetic fields and blasted outward in narrow, powerful jets, streams of plasma moving near the speed of light. These jets can stretch far beyond the host galaxy itself, reaching lengths of millions of light years. We see them glowing in radio wavelengths, forming enormous lobes that mark their reach. Galaxies like these are called radio galaxies, and their jets are among the largest structures in the universe. It's a strange irony. The most powerful outflows can come from the regions around black holes, where light can barely escape. Even silence, it seems, can leave a mark. There's a star that orbits the Milky Way backward. Most stars in the Milky Way orbit in the same general direction, following the galaxy's rotation. But not all of them. There's at least one known star that moves in the opposite direction. Its orbit is retrograde, cutting against the flow like a salmon swimming upstream. How did it get that way? One possibility is that it was part of a smaller galaxy that merged with the Milky Way long ago, and its orbit reflects that older, different system. Or it may have been flung into its current path by a gravitational slingshot, perhaps involving a black hole or dense star cluster. Either way, it's a quiet reminder that not all stars follow the rules, and even in the vast clockwork of the galaxy, there are wanderers going their own way. The center of the galaxy smells like raspberries and rum. It sounds like a joke, but it's real. Astronomers studying the chemical composition of a dust cloud near the center of the Milky Way discovered a molecule called ethyl formate. On Earth, it's associated with the flavor of raspberries and the scent of rum. Of course, the galactic center doesn't actually smell. The vacuum of space wouldn't carry scent the way air does. But the presence of these molecules hints at the complex organic chemistry unfolding in deep space. There are alcohols, sugars, and even amino acid precursors in interstellar clouds. It's not life, but it's the kind of chemistry life might need. So, while space may not smell like fruit and liquor, it contains the building blocks floating silently between the stars. One galaxy is headed straight for the Milky Way, and it's already touching. The Andromeda Galaxy is our nearest large galactic course with the Milky Way. Right now, it's about 2.5 million light-years away, but that gap is closing. In about 4 billion years, the two galaxies will begin to merge. And interestingly, the outer halos of both galaxies, their vast clouds of hot gas and dark matter, are already overlapping. So, in a sense, they've begun touching already. The eventual merger will be more of a graceful blending than a crash. Stars will mostly pass by one another without colliding. Over time, the two spirals will become one larger, elliptical galaxy. We sometimes call this future system Milkomeda. It's a long wait, but it's already in motion, a cosmic meeting playing out over billions of years. The cosmic microwave background still glows all around you. Every part of the universe, including the space around you right now, is filled with a faint glow called the cosmic microwave background. It's the afterglow of the Big Bang, light released when the universe was about 380,000 years old. Back then, the cosmos was a hot, dense plasma. When it cooled enough for atoms to form, light was finally free to travel. That light has been moving ever since, stretched into microwaves by the expansion of space. Today, we detect it as a nearly uniform glow in all directions. It's not something you can see or feel, but sensitive instruments can pick it up as a kind of cosmic whisper. This glow is the oldest light we can observe, a quiet signal from the universe's childhood, still echoing through space and time. Some supernovae are powered by invisible collapse, not light. Supernovae are known for their brightness, massive explosions that briefly outshine entire galaxies. But not all supernovae are luminous. Some are what astronomers call failed supernovae. In these cases, a massive star's core collapses, forming a black hole. But the outer layers don't explode outward in a visible flash. Instead, they may fall inward, feeding the black hole silently. In rare instances, we've watched stars that seem stable suddenly vanish from view. No explosion, no fading glow, just darkness. These disappearances suggest a collapse so complete that almost all of the energy is swallowed. There's still tremendous violence, but most of it is hidden. It's a reminder that not all cosmic deaths make noise. Some happen in silence, deep inside gravity's grip. There are entire galaxies made mostly of gas and dark matter. We often picture galaxies as bright spirals or glowing ellipticals filled with billions of stars. But some galaxies are barely visible at all. These dim systems contain very few stars, but they still have mass, mostly in the form of gas and dark matter. They're difficult to detect with regular telescopes, and often appear only as faint smudges or through indirect measurements. Some of these galaxies may be failed systems, structures that never formed many stars, perhaps because they were stripped of gas or heated too early in cosmic history. Others may be temporary phases in galactic evolution. What they all have in common is subtlety. No fireworks, no spiraling arms, just quiet gravitational presence. They remind us that not all galaxies shine. Some simply exist. Black holes can collide and merge in cosmic dances. When two black holes orbit one another, they emit ripples in space-time called gravitational waves. As energy leaks away, the black holes spiral inward until they merge in a final dramatic moment, two invisible giants becoming one. These collisions don't make light, but they send out bursts of gravitational waves that we can now detect on Earth. The first of these signals was observed in 2015, confirming a century-old prediction by Einstein. Since then, we've detected dozens more. Each one tells a story about massive objects colliding in distant galaxies long ago. These black hole mergers happen quietly, invisibly, but with incredible force, converting entire solar masses of energy into waves that ripple across the universe. And for a moment, the fabric of space itself sings. Some stars die in slow motion, taking billions of years to fade. Not every star ends in a sudden explosion. Smaller stars, like our Sun, die much more slowly. After burning through their hydrogen fuel, they expand into red giants, shedding their outer layers into space. What remains is a dense, hot core, a white dwarf. This remnant no longer produces energy. It simply radiates away its leftover heat very, very slowly. A white dwarf can take billions of years to cool, gradually dimming until it becomes invisible, a black dwarf. But the universe isn't old enough for that to have happened yet. Every white dwarf that ever formed is still glowing somewhere, quietly fading in the dark. The death of these stars is less like a firework and more like an ember, cooling gently over cosmic time. Time near a black hole slows down compared to Earth. In Einstein's theory of general relativity, gravity doesn't just pull on matter, it bends space and time. The stronger the gravitational field, the slower time flows relative to areas of weaker gravity. Near a black hole, where gravity is extreme, this effect becomes dramatic. If you were to orbit just outside the event horizon, time for you would pass much more slowly than for someone far away. Minutes near the black hole could mean years elsewhere. This isn't science fiction, it's a real, measured effect called gravitational time dilation. We've even observed it in milder form with GPS satellites. Around black holes, it becomes profound. In a way, they don't just trap light, they stretch time itself. The void between galaxies is colder than any lab on Earth. Far from stars, planets, or even gas clouds, the vast spaces between galaxies are astonishingly cold. The temperature there drops to just a few degrees above absolute zero, about 2.7 Kelvin. That's colder than any natural place on Earth, and colder than most environments we can create even in advanced laboratories. This chill comes from the near-total absence of particles and energy. There's nothing to hold heat, just a scattering of stray atoms and the faint microwave glow of the early universe. These intergalactic voids are the quietest, loneliest places we know, enormous and empty, stretched across millions of light years. They are the universe's deepest shadows, holding only the background whisper of creation. The universe is getting more transparent as it ages. In the early universe, light couldn't travel freely. The cosmos was filled with a hot plasma, a fog of free electrons and atomic nuclei that scattered photons constantly. But as the universe expanded and cooled, it reached a point where electrons combined with nuclei to form neutral atoms. Suddenly, light could move unhindered. This event, called recombination, happened about 380,000 years after the Big Bang, and it released the cosmic microwave background we still detect today. Since then, the universe has continued to grow more transparent. The formation of galaxies and stars added new pockets of light, and as matter spreads out, there's less and less to block a photon's path. With time, the darkness has become clearer. Space, once glowing and opaque, now lets light pass through almost unimpeded. The first stars were giants, short-lived and fierce. The earliest stars, born when the universe was still young, were unlike most we see today. They were immense, hundreds of times more massive than the Sun, blazing hot and bright. These giants lived short lives, burning through their fuel in just a few million years before collapsing in powerful supernova. With no heavy elements to temper them, They were made almost entirely of hydrogen and helium, pure children of the Big Bang. Their light pierced the darkness of the early universe, beginning the long process of reionization that made space transparent. Though none of these first stars survive today, their echoes remain in the elements they forged and the galaxies they helped shape. They were the first lanterns in a dark cosmos, brief but vital, laying the foundations for every star, planet, and world that would come after. They forged the first heavy elements in their cores. Within the blazing hearts of those early stars, nuclear fusion worked tirelessly. Hydrogen fused into helium, then into heavier and heavier elements as the stars aged. But only the most massive could go further, creating carbon, oxygen, and even iron before collapsing. When they exploded as supernova, these elements were scattered into space, mixing with the raw hydrogen and helium that still lingered. These heavy elements became the building blocks of later generations of stars, and eventually of planets and life. Without the furnaces of those ancient stars, the universe would contain no iron for blood, no carbon for cells, no oxygen for breath. To realize this is to see stars not only as lights in the sky, but as alchemists, forging the ingredients of life. We are the children of their fire, shaped by the remnants of their blazing cores. Every atom in your body was born in a star. The calcium in your bones, the oxygen in your breath, the carbon in every cell, all of it was forged in stars. Long before Earth existed, stars lived and died, scattering their elements into the galaxy. Over countless cycles, these elements gathered into new clouds, which collapsed to form new stars, new planets, and eventually, us. You are, quite literally, made of stardust. This is not a metaphor, but a scientific truth. Without the alchemy of stars, there would be no matter to build life. When you look up at the night sky, you are looking at your own history, written in fire and fusion. Every twinkle is a reminder that we are deeply connected to the cosmos, our very bodies built from its remnants. To rest beneath the stars is to rest among family, kin to the universe itself. Some regions of the universe are expanding away from us forever. The universe is expanding, and that expansion is accelerating. As space stretches faster and faster, some galaxies are being pushed away so rapidly that their light will never reach us. Even if we waited forever, the space between us and those galaxies would grow too quickly for the light to close the gap. They've already passed a point of no return, slipping beyond the cosmic event horizon. Eventually, more and more of the universe will fade from view. Not because it's gone, but because its light can no longer reach us. This isn't something we'll feel day to day, but over billions of years, it means the visible universe will shrink. The cosmos isn't just growing, it's also quietly letting go. Some black holes may be primordial, born before stars. Most black holes form from the collapse of massive stars, but there's another possibility. Black holes that formed in the earliest moments of the universe, before stars even existed. These are called primordial black holes. They may have formed from tiny fluctuations in the dense, hot conditions just after the Big Bang. Regions where gravity pulled matter together into ultra-compact knots. Some of these black holes could be incredibly small. Others might have grown over time. We've never directly detected one, but if they exist, they could help explain dark matter, seed the formation of galaxies, or unlock new insights into the early universe. They'd be older than stars, older than galaxies, silent fossils of the first seconds after time began. Entangled particles may link distant corners of the cosmos. Quantum entanglement is one of the strangest phenomena in physics. When two particles are entangled, their properties remain linked, no matter how far apart they are. Change one, and the other changes instantly, even across vast distances. It doesn't transmit information faster than light, but it does suggest that reality at the quantum level is deeply interconnected. Some physicists think entanglement could play a role in the fabric of spacetime itself, maybe even helping to hold space together. In theory, particles created in the early universe could still be entangled today, stretched across the expanding cosmos. If so, there may be quiet, invisible threads connecting distant regions, quantum echoes from the dawn of time, still present in the emptiness between galaxies. Even empty space hums with quantum fluctuations. At first glance, a vacuum seems like nothing at all, but on the smaller scales, even empty space is restless. Quantum physics tells us that pairs of particles and antiparticles flicker in and out of existence constantly, borrowing energy for a moment before disappearing again. This jittery dance is called quantum fluctuation, and it happens everywhere, all the time. Though fleeting, these tiny events may have shaped the universe itself. The ripples in the early cosmos, which grew into galaxies and clusters, may have begun as quantum fluctuations, stretched by cosmic inflation. What looks like nothing is, in truth, a froth of activity, subtle and unseen. To imagine this is to realize that emptiness is never truly empty. It is alive with potential, humming quietly beneath reality, a hidden foundation for all that exists. The universe began in a fiery expansion we call the Big Bang. More than 13 billion years ago, everything we know, space, time, matter, and energy, was compressed into a single, hot, dense state. In an instant, it began to expand. This moment, called the Big Bang, was not an explosion into space, but the stretching of space itself. From that first fiery expansion came all the seeds of the cosmos, the galaxies, the stars, the planets, and life itself. Though the idea can feel overwhelming, its traces are written in the sky, in the glow of the cosmic microwave background, and in the motions of galaxies still rushing apart. To know the universe began in such a moment is to feel both small and deeply connected. Every star you see tonight, every atom within you, began in that single cosmic unfolding, when time itself first began its endless journey. For a fraction of a second, space expanded faster than light. In the very first heartbeat after the Big Bang, the universe went through a phase called inflation. In less than a trillionth of a second, space itself expanded faster than the speed of light, swelling the cosmos unimaginably in an instant. This rapid growth smoothed out the universe, stretching tiny quantum fluctuations into vast ripples that would one day seed galaxies and stars. Though we cannot see inflation directly, its fingerprints remain in the structure of the cosmos all around us. To imagine it is almost impossible, a moment when distances greater than galaxies grew from something smaller than an atom. And yet, without it, the universe would be uneven, chaotic, and nothing like the graceful web we see today. Inflation was the silent breath that set the stage for everything that followed, the very first whisper of the cosmos as we know it. Gravitational waves travel at the speed of light. Gravity doesn't just pull, it can ripple. When massive objects like black holes or neutron stars collide, they send waves through the fabric of spacetime itself. These gravitational waves stretch and squeeze space as they pass, moving outward in all directions. And they travel at the speed of light, the fastest possible speed in the universe. It took decades to develop instruments sensitive enough to detect them, but now we can listen to these cosmic ripples from Earth. Each wave carries information about distant cataclysms, how much mass was involved, how fast the object spun, even how warped space became. Gravitational waves are silent to our ears, but they are real, measurable, and surprisingly gentle, tiny shudders in the deep structure of the cosmos. The cosmic web connects galaxies across the universe. If you could map the positions of galaxies on the largest possible scale, you'd find something beautiful, a vast, interconnected pattern of filaments and voids called the cosmic web. Galaxies don't sit alone in space. They gather along invisible threads of dark matter and gas, stretching like tendrils between clusters. Where filaments cross, we find superclusters, enormous knots of galaxies. Between them lie immense, quiet voids, almost empty. The cosmic web isn't something we can see with a telescope all at once, but its structure emerges from large surveys of the sky. It resembles a network, or a foam, or even the branching patterns of neurons. It's the shape of the universe on its grandest scales, not random, but woven, like something grown rather than built. The James Webb Telescope can see galaxies that no longer exist. The James Webb Space Telescope was built to look farther than ever before, and in doing so, it also looks farther back in time. Because light takes time to travel, distant galaxies appear to us as they were billions of years ago. Some of the galaxies Webb observes may no longer exist in the form we see them. They may have merged, faded, or changed entirely, but their light is still arriving, a snapshot frozen in time, still crossing space long after the source has changed. This is one of the quiet oddities of astronomy. Telescopes don't show us what's out there now. They show us what was at different moments across the history of the universe. Every deep field image is also a time machine, a gallery of vanished light. A second near a black hole could be years far away. Imagine standing near the edge of a black hole. To you, each second feels ordinary, passing as it always does. But if someone far away were watching, your seconds would stretch into years. This is the effect of gravitational time dilation taken to its extreme. The immense pull of the black hole slows time so dramatically that an entire lifetime could pass for someone near it, while only moments slip by for those far from its reach. In science fiction, This idea often fuels stories of travelers returning home to find centuries gone. If it is no mere story, the math of relativity shows it to be real. To think that time itself can stretch and warp depending on where you are is humbling. Near a black hole, the border between minutes and millennia blurs, and reality itself bends into strangeness. Light from the early universe is stretched into gentle red. As the universe expands, the light traveling through it is stretched. What began as brilliant short wavelengths slowly lengthens, softening into redder hues. This effect, called redshift, is why the light from distant galaxies appears shifted toward red. The space between us and them has expanded during its journey. The farther away a galaxy is, the more its light is stretched, carrying with it a record of how the universe has grown. Some of the oldest light we see from galaxies billions of light years away has shifted so far that it now lies in the infrared, invisible to our eyes. With special telescopes, astronomers capture this softened glow, peering back into cosmic history. It is as if the universe itself sings in lower and lower tones as it ages, stretching its light into a gentle red, a quiet record of time's expansion. Some galaxies glow in ultraviolet beyond human eyes. Not all galaxies shine in colors we can see. Some glow most strongly in ultraviolet light, invisible to human eyes, but detectable with special instruments. These galaxies are often bustling with newborn stars, which radiate in the hottest, brightest part of the spectrum. To us, they would look faint or ordinary, but through ultraviolet vision, they blaze with intensity. Their spiral arms threaded with bright patches of starbirth. It is like a secret version of the universe hidden just beyond the limits of our senses. Telescopes such as the Hubble have revealed this unseen beauty, mapping galaxies in wavelengths our eyes cannot detect. They remind us that what we see is never the whole story. Beyond our narrow vision, the cosmos shines with colors and patterns invisible to us, yet woven deeply into the fabric of creation. The universe may be infinite. When we look up at the stars, it's natural to wonder if there's a boundary somewhere, an edge to everything. But current observations suggest that space might go on forever. We can only see a finite region, the observable universe, but beyond that, the universe may continue without limit. No edge, no center, just more galaxies, more stars, more space. If that's true, it means that most of the universe will always be beyond our reach. We'll never see all of it, no matter how far we look or how long we wait. An infinite universe doesn't mean infinite possibilities, but it does mean endlessness, a quiet vastness that stretches on gently and without conclusion. Cosmic rays strike Earth from deep space. Every second, high-energy particles called cosmic rays hit our planet. Some from the sun, others from distant parts of the galaxy or even beyond. They're made of protons, atomic nuclei, and other fragments accelerated to incredible speeds by exploding stars, black holes, or mysterious cosmic forces. Most are deflected by Earth's magnetic field or absorbed by the atmosphere, but some reach the surface, and a few even pass through you. These particles are mostly harmless in small doses, but they're a quiet reminder that space is not empty. It's alive with motion, energy, and invisible messengers from far-off events. Every now and then, a cosmic ray hits a detector and tells a story that began light years away, a particle's journey from a supernova to your sky. There may be no such thing as before the Big Bang. The phrase before the Big Bang seems natural, but it may not make sense. According to general relativity and many cosmological models, time itself began with the Big Bang. That moment wasn't just the birth of matter and energy. It was also the beginning of space and time as we know them. Asking what came before is a bit like asking what's north of the North Pole. Some theories suggest a previous state or universe, while others describe a quantum realm where time behaves differently or doesn't exist at all. But in most models, before the Big Bang isn't a place we can visit, even in thought. The Big Bang wasn't an explosion in space. It was the beginning of space. Some planets circle so close that they are torn apart. Some planets orbit so close to their stars that they are locked in a perilous embrace. Gravity stretches them, pulling their shapes into oval, while intense heat strips their atmospheres away. In the most extreme cases, these worlds are literally torn apart, their matter pulled off and devoured by the star itself. These planets are often called hot Jupiters or ultra-close exoplanets, circling in just days or even hours. The forces they endure are unimaginable, shaping them into strange forms and leaving behind trails of gas streaming across space. They remind us that not all orbits are safe or stable. Some worlds live on the edge of destruction, held too close to the very stars that once gave them life. To picture them is to feel the power of gravity itself, shaping destinies with no escape. Some are so distant they take millennia to complete an orbit. While some planets skim close to their stars, others wander far on enormous paths. These distant worlds may take centuries, even millennia, to complete a single orbit. Their skies are dim, their warmth faint, and yet they remain bound by gravity, tracing their endless loops around the stars that hold them. In our own solar system, the dwarf planet Sedna takes more than 10,000 years to travel once around the Sun. Farther out in other systems, there may be worlds even more remote, drifting in the thin light of their suns. Imagine a year that lasts longer than human civilization itself, a world where seasons unfold across entire ages. These planets move at the very edge of belonging, still tied to their stars, yet almost free. They remind us how vast space is and how many ways a planet can live. Moons may outnumber planets by the trillions. Planets may be rare jewels of the cosmos, but moons may be even more common. Around gas giants, around rocky worlds, even around dwarf planets, moons gather in abundance. Some are larger than planets themselves, with atmospheres and hidden oceans. Others are small, captured asteroids pulled into orbit long ago. In our solar system, moons outnumber planets by far. And if we look beyond, it is likely the same across the galaxy. Trillions of moons may circle their worlds, shaping tides, sparking volcanism, and sometimes even nurturing life. Europa, Enceladus, Titan, these moons in our own neighborhood already hint at the possibilities. Each is a world in miniature, unique in its landscapes and mysteries. To think of the universe filled with moons is to imagine a cosmos of endless companions, circling quietly in the glow of their parent worlds. In the distant future, stars will stop being born. Star formation depends on cold gas, clouds of hydrogen and helium that collapse under gravity. But over time, this fuel becomes scarce. It gets locked up in stars, blown away by supernova, or heated beyond usefulness. Billions of years from now, galaxies will run out of the material needed to form new stars. The ones that remain will age, burn out, and fade away. First, the blue giants, then the suns, then the red dwarfs, until even the slowest burning embers cool into blackness. The universe won't end all at once. It will dim by degrees, quietly and gently. What's left will be black holes, white dwarfs, neutron stars, and the silence of a cosmos grown cold. Not tragic, just still. Most matter in the universe is invisible. When we look at the universe, stars, galaxies, nebulae, we are only seeing a small fraction of what's really there. Most of the matter in the cosmos doesn't shine. It doesn't emit or reflect light. This invisible substance is called dark matter, and although we've never detected it directly, we know it exists because of its gravitational effects. Galaxies spin faster than they should. Light from distant objects bends more than expected. Clusters hold together with more strength than their visible mass allows. All of this suggests a hidden mass, more than 5 times the amount of ordinary matter. Dark matter is everywhere, shaping the structure of the universe. We just can't see it. It's a quiet, invisible framework, holding everything else in place. Light from the first galaxies has been stretched by cosmic expansion. When light travels through space, it doesn't just move, it stretches. That's because the universe itself is expanding, and as it grows, it pulls light waves along with it. The light that left the first galaxies billions of years ago has been stretched into longer wavelengths, moving from visible light into the infrared. This process is called redshift, and it's one of the main ways astronomers measure distance and time in the universe. The more stretched the light, the farther and older its source. With telescopes like James Webb, we can finally see that ancient light, now softened and reddened by the journey. What began as the glow of young stars now arrives as a whisper, stretched by the breath of space itself. Some worlds are covered entirely in oceans. Imagine a planet where there is no land at all, only endless ocean stretching in every direction. Astronomers call them ocean worlds, and they may be common in our galaxy. These planets are covered in deep layers of water, perhaps hundreds of kilometers thick, with currents, storms, and waves rolling across their entire surfaces. Beneath, there may be high-pressure ices or even hidden oceans warmed by internal heat. If life were to evolve there, it would live in seas without shorelines, drifting forever in alien tides. Even in our solar system, moons like Europa and Enceladus hint at vast hidden oceans beneath their icy shells. To think of a planet entirely given to water is to imagine something both familiar and strange, a world like Earth, yet without continents, only an eternal sea under foreign stars. Some planets burn with seas of lava. At the other extreme, a world so close to their stars that their surfaces are oceans of fire. Temperatures soar high enough to melt rock, creating vast seas of lava that churn and glow like rivers of molten metal. Some of these planets are called lava worlds, where dayside heat is unbearable, while the nightside may freeze into stillness. The contrast can be extreme, one half blazing, the other silent and cold. These planets remind us how violent and varied the cosmos can be. To imagine standing on one is impossible. The ground itself would ripple with heat, and the sky would shimmer with burning light. Yet they exist, circling in tight, dangerous orbits, showing us what happens when gravity pulls a world too close to its star. They are fiery reminders of how delicate balance must be for life to thrive. Some planets rain diamonds in their skies. Far from Earth, in the crushing atmospheres of giant planets like Neptune or Uranus, carbon may fall as rain. But instead of water, the pressure and heat transform it into diamonds. These glittering crystals form deep in the atmosphere, tumbling downward like gems from a hidden storm. On some worlds, scientists think the entire mantle could be made of diamond, forged by unimaginable pressures. Even exoplanets far away may experience the same. It's a vision both surreal and beautiful, rain that sparkles, not with drops of water, but with shimmering jewels. The universe, in its variety, creates weather beyond anything Earth has ever known. To drift asleep imagining a storm of diamonds falling endlessly through alien skies is to realize just how strange and how wondrous other worlds might truly be. The universe could end in a slow, quiet fade. Cosmologists once wondered if the universe would collapse back in on itself, but the evidence now suggests a different fate: slow, endless expansion. As galaxies drift farther apart and star formation slows, the night sky will grow darker. Existing stars will burn out one by one. Black holes will evaporate. Matter itself may decay, and the universe will become colder, quieter, and emptier, a state called heat death. It's not a sudden event, but a long, gentle fade. Over the trillions of years, the cosmos will grow still as energy spreads thin and structures dissolve. It's not the end as fire or ice, but as silence, a universe that whispered itself into being, and eventually whispered itself away. Some galaxies have super winds that blow away stars. At the heart of some galaxies, especially those with active black holes or intense star formation, powerful winds can blow out from the center, carrying gas, dust, and even young stars with them. These galactic super winds can stretch for tens of thousands of light years, pushing material into intergalactic space. They're driven by radiation, magnetic fields, and the explosive energy of supernova. Over time, these winds can strip a galaxy of its star-forming gas, leaving it quiet and red. They also help spread heavy elements into the cosmic web, seeding future generations of stars and planets. In this way, a galaxy breathes, taking in matter, igniting life, and then exhaling into the void. The far future of the cosmos is an endless dark ocean. Trillions of years from now, the universe will look very different. Galaxies will have drifted apart so far that each one will seem alone in the dark. New stars will stop forming. Old stars will burn out. Even the faint glow of white dwarfs will fade. What remains will be cold, scattered remnants, black holes, and the thin echo of ancient light. Over unimaginably long timescales, black holes will evaporate, and even matter itself may decay. Eventually, all that remains will be particles moving through empty space, silent, slow, and alone. This future is called the heat death of the universe, but it's not a sudden end. It's a vast, dark stillness, a cosmic ocean with no waves, no wind, and no shore. There are stars so large they could swallow our solar system. Among the giants of the cosmos are hypergiant stars, swollen to unimaginable proportions. Some are so vast that if placed where our Sun is, they would stretch beyond the orbit of Jupiter, swallowing Mercury, Venus, Earth, and Mars within their blazing atmospheres. These colossal stars burn fiercely, living fast and short lives compared to smaller suns. Their outer layers expand outward like vast shimmering veils of gas, trembling at the edge of collapse. From afar, they glow with an intensity that can outshine hundreds of thousands of ordinary stars. Yet, their very size is also their undoing. They are unstable, prone to shedding their mass in great storms of gas, and destined to in catastrophic explosions. To imagine such a star is to feel the scale of the universe, immense, fiery, and humbling, beyond anything we could ever witness up close. Some stars are barely bigger than a planet. At the opposite extreme, there exist stars so small they blur the line between planets and suns. These are red dwarfs, the most common type of star in the galaxy. Some are only a little larger than Jupiter, glowing dimly with cool red light. Though small, they are stable and can live for trillions of years, far longer than the universe has yet existed. Around many of these faint suns, planets circle quietly, perhaps warmed just enough for oceans and skies to form. To us, they are almost invisible without telescopes, hidden by their faintness, but they make up the majority of stars in the Milky Way. If life is abundant in the universe, it may be these quiet, long-lived stars that host the greatest number of worlds. They remind us that greatness in the cosmos is not always about size or brilliance, but endurance. Pulsars spin with the precision of cosmic clocks. When massive stars explode, their cores may collapse into neutron stars, objects so dense that a teaspoon of their matter would outweigh mountains. Some of these neutron stars become pulsars, spinning rapidly and beaming radio waves from their magnetic poles. As they rotate, these beams sweep across space like the beam of a lighthouse. To observers on Earth, pulsars appear to pulse with astonishing regularity, ticking like cosmic clocks with a precision unmatched by almost anything in nature. Some spin many times each second, their rhythm steady for millions of years. Pulsars have helped astronomers test theories of gravity, map the galaxy, and even discover planets. Yet, they are also haunting reminders of the power of collapse, the remnants of stars once blazing, now reduced to tiny spinning embers, flashing endlessly in the dark, steady as time itself. Black holes can twist space into a funnel of time. A black hole doesn't just trap light, it warps spacetime itself. As you approach its event horizon, space bends inward and time slows down. To an outside observer, time near the black hole appears to crawl. At the very edge, it almost stops. This warping creates something like a funnel in the geometry of space, narrow, steep, and one-way. Inside, all paths lead toward the center, the singularity. The closer you get, the more time and space seem to trade places, with inward becoming a direction in time, not space. You can't go back. This twisting of spacetime is more than metaphor. It's geometry, drawn by gravity, written in the fabric of reality itself. Some regions of the universe may never see each other again. Because the universe is expanding and accelerating, some parts of it are already moving apart faster than light can travel. This means that even if we wait forever, a light from those regions will never reach us. The same is true in reverse. There are places we can never send a message to because the space in between is stretching too quickly. Over time, more and more of the universe will slip beyond reach. Each galaxy will become an island, isolated in space, surrounded by darkness. This doesn't break the laws of physics. Nothing is moving through space faster than light, but space itself can grow calmly and unstoppably, separating one piece of the cosmos from another forever. The heaviest element made in a star explosion is gold. Gold is rare on Earth, not just in our economy, but in the universe itself. It can't be made in the core of an ordinary star. Instead, it forms in the most extreme events, the collisions of neutron stars or certain kinds of supernova. In those moments, atomic nuclei are smashed together under incredible pressure and heat, creating heavy elements like gold, platinum, and uranium. These precious atoms are then scattered into space, mixed into gas clouds, and eventually become part of new stars, planets, and people. Every gold ring, every fleck of dust, was born in a cosmic catastrophe, a quiet trace of violence now resting on your hand. In that sense, gold is not just beautiful, it's ancient. It's stellar, and it came from a universe that forges treasure in fire. There are stars that end in explosions bright enough to outshine galaxies. Some stars live fiercely and end suddenly in an explosion called a supernova. When their fuel runs out, their cores collapse under immense gravity, and in an instant, the star releases a wave of energy so powerful it can outshine an entire galaxy for weeks. These cosmic fireworks scatter heavy elements across space: iron, gold, calcium, carbon, the very ingredients of planets, oceans, and life itself. Without supernova, Earth could never have formed. To witness one is rare and astonishing. Astronomers on Earth have recorded them throughout history, sometimes appearing as sudden new stars bright enough to be seen in daylight. Yet, they are not endings alone. Each explosion is also a beginning, enriching the universe so that new stars, new planets, and perhaps new life can emerge. In the vast cycle of creation and destruction, even death brings light. Our Milky Way contains hundreds of billions of stars. When you look up at the night sky, you see only a handful of stars. Yet, our galaxy, the Milky Way, contains hundreds of billions. Most are too faint or too distant for our eyes to see unaided, but together they form a great spiral disk stretching more than 100,000 light-years across. Within it are stars like the Sun, stars larger and brighter, and others barely glowing. Our galaxy is a vast starry city, its spiral arms threaded with gas clouds where new stars are born. To us on Earth, the Milky Way appears as a pale band across the sky, but in truth, that hazy glow is the combined light of countless suns. To realize that every point of light belongs to this enormous family is humbling. We live within a single galaxy, one among trillions, carrying the quiet glow of ancient starlight. At its heart lies a supermassive black hole. Deep in the center of the Milky Way lies Sagittarius A*, a supermassive black hole more than 4 million times the mass of our Sun. Invisible on its own, its presence is revealed by the way stars whirl around it, orbiting at incredible speeds, as though caught in the grip of an unseen giant. If you could stand near it, time itself would slow, light would bend, and space would stretch toward the abyss. Yet, most of the time, it rests quietly, cloaked in darkness. Occasionally, it flares as gas drifts too close and vanishes into its depths. To know that such a monster resides at the heart of our home galaxy is both unsettling and awe-inspiring. And yet, it has been there since the Milky Way's earliest days, shaping its history, and quietly keeping its place at the very center of our cosmic neighborhood. There are stars that flicker like fireflies in the night. Not all stars shine with steady light. Some pulse, shimmer, or dim and brighten in rhythmic patterns. These variable stars change for many reasons: internal pressure waves, surface eruptions, or eclipsing companions. From Earth, they look like they're flickering gently in the sky, blinking with a slow stellar rhythm. Some complete their cycle in hours, others in years. These variations aren't random. Many are remarkably consistent, acting like celestial clocks. Astronomers use them to measure distances across the universe. A single flicker repeated over and over can tell us how far away a star is, and even how bright it truly is. Stars don't just burn. Some of them breathe. Some black holes wander through space alone. Not all black holes live in the centers of galaxies. Some roam. A black hole can be ejected from its birthplace by gravitational interactions, kicked out of a galaxy during a collision, or flung away by the recoil of a merger. Once released, it becomes a rogue object moving silently through interstellar or even intergalactic space. These wandering black holes are hard to detect. They emit no light unless they pass through gas or pull on nearby stars. But they're likely out there, drifting through darkness, unseen and unbound. They carry no orbit, no companion, no home. Just mass, motion, and the deep gravity of a thing that fell inward and never stopped falling. Even black holes can get kicked across the galaxy. When two black holes merge, the violent event sends out a burst of gravitational waves. But those waves aren't always symmetrical. If the merger sends more energy in one direction, it can give the new black hole a kind of recoil, a gravitational kick strong enough to hurl it away at thousands of kilometers per second. Some black holes may be flung entirely out of their galaxies, doomed to drift through intergalactic space. Others settle into wide, wandering orbits. These kicked black holes are hard to spot, but astronomers believe they exist. Silent travelers pushed by the memory of their own collision. Even the heaviest, most anchored things in the universe can be moved by the right kind of wave. Ancient starlight travels for billions of years before reaching us. Every time you look up at the stars, you are looking into the past. Light does not travel instantly. It takes time to cross the gulf of space. The light from our Sun is 8 minutes old by the time it touches Earth. The light from the nearest stars may be decades old. And the faintest galaxies we see through telescopes send us messages that have been traveling for billions of years, crossing most of cosmic history to reach our eyes. In a way, the night sky is a vast time machine, showing us the universe as it once was. Some of the stars we see may no longer exist, their lights still racing onward long after they have faded. To watch the stars is to catch whispers of ancient stories written in photons, carrying memories across the ages. A faint cosmic glow still echoes from the birth of the universe. Long ago, the universe was a hot, glowing sea of particles. As it expanded and cooled, light finally broke free and began its long journey outward. That ancient light still exists, stretched into faint microwaves by billions of years of cosmic expansion. We call it the cosmic microwave background, a dim glow that fills the entire sky, invisible to our eyes but detectable with sensitive instruments. It is the afterglow of the Big Bang, a relic from when the universe was just a few 100,000 years old. To map it is to see the first ripples of structure, the seeds of galaxies and stars that would one day form. Quiet, ancient, and everywhere, this glow is the universe's oldest light, a whisper from its fiery beginning still surrounding us as we drift through space. An invisible web of dark matter holds the galaxies together. Though galaxies are made of stars, gas, and dust, these visible pieces are not enough to explain how they move. Something unseen must be at work, holding them in place. That something is called dark matter, an invisible form of matter that does not shine, does not glow, and cannot be touched, but outweighs all the stars we see. Dark matter forms a vast hidden web. Its gravity sculpting the large-scale structure of the cosmos. Galaxies are like beads caught along its threads, bound together by its invisible hand. Though we cannot see it, we can measure its presence in the motions of stars and the bending of light. To imagine the universe without dark matter is impossible. It is the silent framework upon which all else hangs. We live inside its shadowy embrace, held by something we cannot yet fully know. The light from a distant star can be twisted by a single planet. We usually think of gravity bending light on a massive scale, by stars, black holes, or galaxies. But even a planet can do it. If a planet passes directly between a distant star and Earth, it can act as a tiny gravitational lens, magnifying and distorting the starlight. This effect is called microlensing. It's subtle and rare, but powerful enough to reveal planets we could never see otherwise, even in other galaxies. A flicker in the light, a gentle curve in the brightness, and suddenly a world is revealed. The planet itself might be cold, dark, and invisible, but its presence twists the starlight ever so slightly, and that twist is enough to say, "I'm here." The universe once glowed with a brilliant orange light. In the early days after the Big Bang, the universe was a hot, dense plasma, glowing with intense light. But as it expanded and cooled, that glow shifted. When the temperature dropped to around 3000 degrees Kelvin, the first atoms formed, and light could travel freely. At that moment, the universe would have looked orange, not the blue-black of night we see now, but a soft, warm radiance filling all of space. This light has since been stretched by the expansion of the universe into the faint microwave glow we detect today, the cosmic microwave background. But long ago, there was a time when the entire cosmos glowed orange, as if lit from within, a quiet ember fading into time. Some parts of the universe are cooling slower than others. As the universe expands, it cools gradually, gently, like a vast oven being turned off. But not every region cools at the same rate. Some areas filled with more matter or trapped light retain heat longer. Clusters of galaxies, for example, contain hot gas that remains warm for billions of years. Other regions are more isolated and chill more quickly. These temperature differences affect how structures form, how stars evolve, and how long certain processes can last. Even in a universe governed by simple rules, there are local variations, warmer pockets, slower fades, small delays in the great unfolding. The universe doesn't cool like a machine. It cools like weather, uneven, textured, and quietly alive. The universe may be infinite, yet we see only a small part of it. When you look into the night sky, you're seeing only the smallest glimpse of what may exist. Our telescopes can peer across billions of light years, yet even then, the universe continues beyond our sight. It may stretch forever, endlessly unfolding, or it may curve back upon itself in ways we cannot yet imagine. What we can see is called the observable universe, a sphere around us limited by the age of light itself. Beyond that boundary, there may be countless galaxies, stars, and worlds hidden not by distance alone, but by the very fabric of time. The thought is both humbling and soothing. We live inside a cosmic horizon, like a small island surrounded by an infinite sea. To gaze upward is to stand at the edge of everything we know, with the possibility that the universe has no edge at all. A mysterious force called dark energy is pushing space apart. Not only is the universe expanding, it is expanding faster and faster, as though pushed outward by a hidden force. Astronomers call it dark energy, a mysterious pressure woven into the fabric of space itself. We do not know what it is, only that it makes up most of the universe, and its effects grow stronger with time. Because of dark energy, distant galaxies are racing away from us more quickly than ever before. And in the far future, they will drift beyond sight altogether. Dark energy is perhaps the greatest mystery in cosmology, a quiet force guiding the destiny of everything. It means that the universe is not static, but alive with motion. A notion of space swelling ever outward. To rest beneath the stars is to feel its gentle pull, carrying all things slowly apart into the unknown. But stay with me, because what comes next is even stranger, an idea so vast it may be the strangest thing you hear all night. Black holes twist space and time into impossible shapes. At the heart of collapsed stars or at the center of galaxies lie black holes. Regions where gravity grows so strong that nothing, not even light, can escape. To approach a black hole is to step into a place where space and time themselves are bent and twisted. Clocks tick more slowly. Light stretches and reddens. To an outside observer, anything falling in seems to freeze at the edge forever. Yet from within, the fall continues unstoppably to a hidden singularity. Some black holes are small, just a few times the mass of our sun, while others are monsters millions or billions of times larger. They are silent, invisible, and mysterious. Yet they shape galaxies and stir the fabric of the cosmos. To imagine them is to confront the strange truth that the universe is not only vast, but stranger than our deepest dreams. We might one day watch the birth of a new universe. Some theories of cosmology suggest that new universes could form within our own, budding off through quantum fluctuations, black holes, or other mechanisms we don't yet understand. If this happens, it would likely occur far from us, beyond any observational reach. But in theory, it might be possible to witness the signs. A sudden expanding bubble of new physics tearing away from our familiar reality. We don't know if this has ever happened. We don't know if it ever will. But the idea remains that somewhere, someday, the quiet darkness of our universe could give birth to something new. A beginning inside an ending. A whisper inside a silence. The cosmos is still ringing from its earliest moments. In the first fraction of a second after the Big Bang, the universe expanded explosively, an event known as inflation. That burst of motion left behind ripples. Tiny quantum fluctuations stretched across space. These ripples became the seeds of all future structure, galaxies, stars, planets. And they also left behind echoes. We see them in the cosmic microwave background as temperature variations, and we may one day detect them as primordial gravitational waves, faint rhythmic pulses in the fabric of spacetime itself. The universe may seem quiet now, but it still carries the memory of that first vibration. Like a bell still humming softly long after the strike. The universe is vast, and you are a way for it to know itself. Of all the strange facts in astronomy, perhaps the most quietly astonishing is this. You are made of stardust. The carbon in your body, the calcium in your bones, the iron in your blood, all were forged in stars, scattered across space, and gathered into life. You are not separate from the cosmos. You are a moment of it made conscious. A flicker of awareness in a universe that otherwise only moves and burns and cools. In this sense, the universe has grown eyes. And through those eyes, it looks back at itself, wonders at itself, dreams of itself. And even now, as you drift towards sleep, it keeps dreaming. Galaxies drift like islands across an endless sea of darkness. Each galaxy is a floating city of stars bound together by gravity, yet adrift in the vastness of space. They glide slowly, silently, across a cosmic ocean. Their spirals and ellipses shaped by billions of years of motion. Our own Milky Way is just one of trillions moving gently through the void, drawn by the subtle pull of its neighbors. Sometimes galaxies approach one another, merging in long, graceful dances that take hundreds of millions of years. Other times, they drift apart, carried on the steady current of cosmic expansion. When we look at a galaxy far away, we see it not as it is now, but as it was millions or billions of years ago, frozen in the past. To imagine them all, scattered like glowing islands across a dark and endless sea, is to glimpse the quiet majesty of the universe. Stars are forged in hidden nurseries of gas and dust. In the quiet depths of space, there are vast clouds of gas and dust, dark, cold, and invisible to the naked eye. Yet within these clouds, stars are born. Gravity gathers the gas together, pulling it inward until pressure and heat ignite a new light. These stellar nurseries are veiled places, glowing softly in infrared, where hundreds or even thousands of stars may form at once. The Orion Nebula is one such nursery, visible from Earth as a hazy patch of light. Yet inside it lies an entire cradle of suns. Every star we see in the sky was once born in such a hidden place, emerging from darkness to shine for millions or billions of years. To know this is to realize that the universe is always growing, always creating. Even now, as we drift to sleep, new stars are kindling their first light. Some stars burn with a gentle glow for billions of years. Not all stars live fast or die young. Some, like our Sun, shine with a steady and patient glow, burning hydrogen slowly in their cores. These stars can endure for billions upon billions of years, giving warmth and light to the worlds that circle them. Their lives are measured not in centuries or millennia, but in ages so vast we can barely imagine them. They rise, shine, and continue while civilizations bloom and fade on planets that may orbit quietly nearby. When you look up at the night sky, many of the stars you see are these long-lived companions of the cosmos, content to glow softly for eons. They are steady candles in a universe of change, constant enough to guide life, and enduring enough to remind us that time, even on the grandest scale, can be gentle and unhurried. Some stars are stripped down to bare cores of pure carbon. When a star like our Sun dies, it sheds its outer layers and leaves behind a core, a white dwarf. Some white dwarfs are made mostly of carbon, and under the immense pressure of their own gravity, that carbon may crystallize. In other words, some stars become giant diamonds. These stellar diamonds are about the size of Earth, but far heavier, glowing faintly with leftover heat. They no longer fuse atoms, but they still shine for billions of years before cooling to blackness. Astronomers have even detected pulsations in some white dwarfs, a kind of ringing, like the sound of a struck bell. A silent, cooling jewel floating in space. Once a star, now a crystal of ancient fire. Most of the universe's history hasn't happened yet. 13.8 billion years sounds like a long time. But if you imagine the entire future of the universe, not just tomorrow or a million years from now, but trillions of years into the future, we are still near the very beginning. Stars are still forming. Galaxies are still assembling. Black holes still shine with the heat of falling matter. In the far future, the stars will fade, the galaxies will drift apart, and the universe will grow cold and quiet. But that chapter hasn't begun yet. Right now, we live in a moment of light, a brief golden season when the cosmos is alive with motion and change. The past is vast, but the future is bigger still. Supernova remnants keep expanding for thousands of years. When a massive star dies, it goes out in a supernova, a brilliant explosion that can briefly outshine an entire galaxy. But the event doesn't end with the flash. The shockwave expands outward for centuries or even millennia, sweeping up gas, dust, and anything in its path. These expanding shells of debris are called supernova remnants. They glow in many wavelengths: radio, X-ray, visible light, and their patterns tell the story of the explosion. Some form delicate filaments, others turbulent clouds. The Crab Nebula is one such remnant, still spreading outward from a blast that was seen on Earth in the year 1054. Supernova remnants are the slow exhalations of dead stars, still unfolding long after the light has faded. Galaxies can collide and merge into something new. Though galaxies look serene from afar, they are not still. Slowly, over billions of years, they drift together and collide. When they do, their stars rarely crash into one another. The spaces between them are too vast, but their gas and dust swirl, compressing into new bursts of star formation. Over time, two galaxies can merge into one larger system, reshaped and reborn. The Milky Way itself is on a slow collision course with our neighbor, the Andromeda Galaxy. In about 4 billion years, the two will begin to merge, creating a single new galaxy that astronomers sometimes call Milkdromeda. From Earth, if life still watches, the night sky will blaze with streams of stars as the two galaxies intertwine. What seems calm now is part of an endless, graceful dance, where galaxies meet, merge, and emerge transformed, more luminous than before. Stars often form in clusters, like families born together. When stars are born in dense clouds of gas and dust, they rarely emerge alone. Instead, they form in clusters, hundreds or thousands at a time, like families born from the same cradle. These clusters can be tight and brilliant, shining as jewels in the sky, or loose and scattered, slowly drifting apart over time. Our Sun, too, was likely born in a cluster billions of years ago, surrounded by sibling stars that have since wandered away across the galaxy. Some of those long-lost siblings may still exist, hidden among the Milky Way's billions. To think that every star has a birth family is strangely comforting. The stars we see at night are not just scattered randomly, but are the children of vast, ancient nurseries. They remind us that even in the cosmos, creation happens in gatherings, where many lives begin together. Some stars travel alone across the galaxy. While many stars are born in clusters, some become wanderers. These lonely stars drift through the galaxy with no companions, expelled from their birthplaces by gravitational encounters or collisions. They are sometimes called runaway stars, traveling at astonishing speeds, flung outward by the dynamics of their crowded homes. Others may simply form in isolation, quiet and solitary, far from bustling clusters. Imagine a star alone in the vast dark, carrying its light across thousands of light years, with no close neighbors, no nearby companions, just empty space stretching in every direction. Some of these solitary stars may even host planets, tiny worlds circling in quiet solitude. Though alone, they remind us of resilience, of endurance, and of the way light continues to shine even when surrounded by silence. The galaxy holds not only great families of stars, but also these solitary voyagers drifting endlessly. The space between galaxies expands while light travels through it. When we observe light from distant galaxies, we are seeing it as it was long ago, but also stretched by the space it moved through. As the universe expands, so does the distance the light has to travel. And that means the light itself is stretched. Its wavelength lengthens, shifting toward the red. This is called cosmological redshift. The light isn't slowing down or losing energy by hitting things. The space it moves through is simply getting bigger. In effect, the universe stretches the signal on its way to us. When we see faraway galaxies, we are seeing more than age or distance. We are seeing how space has changed since the moment that light began its journey, a silent record of the universe's steady breathing. There are sound waves frozen into the structure of the cosmos. In the early universe, before atoms formed and light could travel freely, matter and energy were tightly coupled in a hot plasma. In that plasma, pressure and gravity created oscillations, ripples of compression and rarefaction, like sound waves in air. These acoustic waves left an imprint in the density of matter, a kind of frozen echo. Today, we can see that echo in the distribution of galaxies, a preferred distance between galaxy pairs, like a standing wave preserved in space. This phenomenon is known as baryon acoustic oscillation. It's subtle, but measurable, a fossil record of cosmic sound ringing out from a time before the universe became transparent. A wave that never fades, quietly shaping the structure of everything we see. Galaxies can be eaten by larger ones without a trace. In the vast timescales of cosmic evolution, galaxies don't just float alone. They interact, collide, and sometimes devour each other. When a small galaxy comes too close to a larger one, gravity can tear it apart. Its stars are pulled into long streams, absorbed into the larger galaxy's halo, and eventually blended so thoroughly that the smaller system vanishes from view. We found remnants of such mergers around the Milky Way, stellar streams arcing through the sky, once part of other galaxies. This process is called galactic cannibalism, but it's slow and elegant, not violent, just inevitable. Over time, large galaxies grow this way, not through building, but through quiet consumption. One galaxy absorbed into another, leaving only a ripple in the stars. Neutron stars pack the mass of suns into a city-sized sphere. Imagine compressing the mass of the sun into a ball no larger than a city. That is a neutron star, one of the densest objects in existence. Inside, matter is crushed into a strange state where protons and electrons fuse into neutrons, packed so tightly that the surface is harder than steel, and gravity is nearly unimaginable. If you could drop a pebble onto its surface, it would strike with the force of a nuclear bomb. Yet, despite their density, neutron stars are only about 20 kilometers across, tiny by cosmic standards. They are the remnants of massive stars that ended in supernova explosions, their cores left behind as these astonishing spheres. Some spin rapidly, others emit bursts of radiation, but all carry the legacy of stars long gone. They are monuments to extremes, small, yet impossibly heavy, glowing softly in the vastness of space. Quasars shine brighter than entire galaxies. Far across the universe, astronomers have found beacons so bright they outshine entire galaxies. These are quasars, powered by supermassive black holes feeding on surrounding gas. As the gas falls inward, it heats to incredible temperatures, releasing light that can travel across billions of light years. Some quasars are so distant that we see them as they were when the universe was young, blazing like cosmic lighthouses in the early darkness. Though they are powered by destruction, they are also signs of creation, marking the growth of galaxies and the shaping of the universe itself. To see one is to peer into both power and mystery, the heart of darkness blazing with light. They remind us that the cosmos is full of contrasts, the most radiant light born from the deepest gravity wells, and brilliance shining from the very edge of nothingness. There may be more planets than stars in the universe. For a long time, astronomers could only guess how many worlds might circle other suns. But now, with telescopes able to detect even the faintest dips of starlight, we know planets are everywhere. Almost every star seems to have at least one, and many host entire families of them. Some orbit close, some drift far, and some systems are unlike anything in our imagination. When you consider that there are hundreds of billions of stars in the Milky Way alone, and trillions of galaxies across the cosmos, it becomes likely that planets outnumber stars themselves. Each one a world with its own history, its own landscapes, its own silent orbit. The night sky above you filled with stars is in truth filled with more unseen planets than shining suns. Countless hidden places circling quietly in the dark. We might be living inside a giant cosmic void. The universe is filled with clusters of galaxies, and between them enormous empty regions called voids. These voids span hundreds of millions of light years, and contain very little matter. Some researchers believe we may be inside one of these voids right now, a relatively underdense region compared to the average cosmic background. If true, it could help explain certain observations, like the expansion rate of the universe, or patterns in the cosmic microwave background. Living inside a void doesn't change our day-to-day life, but it means that what feels like emptiness may be part of a much larger structure, the quiet middle of a cosmic bubble gently drifting through a web of invisible gravity. Magnetars have magnetic fields trillions of times stronger than Earth's. A magnetar is a type of neutron star, a city-sized remnant of a collapsed star, with an unimaginably powerful magnetic field. Earth's magnetic field is enough to guide a compass. A magnetar's field is so strong it could erase data from thousands of miles away, distort atomic structures, or tear matter apart. These fields are temporary, decaying over time, but while they last, they produce flares and bursts of high-energy radiation. A single magnetar flare, even from across the galaxy, can be detected on Earth. No lab could create such intensity. They're among the most extreme objects in the universe, dense, silent, and wrapped in invisible force, like stars that have become nothing but memory and magnetism. The universe's largest known object is a giant quasar group. In 2013, astronomers discovered a vast structure made up of quasars, the luminous cores of distant active galaxies, stretching over 4 billion light-years across. This structure, called a large quasar group, is so big it challenges our understanding of cosmic uniformity. According to current theory, the universe should be relatively smooth on the larger scales, with no structures exceeding a certain size. But this quasar group is larger than that theoretical limit. It's made of dozens of quasars connected across an enormous stretch of space, suggesting that the early universe may have formed larger patterns than we once thought. Whether it's a true physical structure or a statistical fluke is still debated. Either way, it reminds us that the universe is more complex, and perhaps more connected, than our models can always predict. There are frozen worlds of ice and ammonia. Not all planets burn with fire. Many drift in the cold outer skirts of their systems, wrapped in layers of ice. These frozen worlds may be covered with ammonia snow, methane glacier, or icy plains stretching endlessly under dim starlight. Some may be solid spheres of frozen gas, while others conceal oceans beneath their frozen crusts. In the distant reaches of our own solar system, objects like Pluto and Triton remind us of this strange category of worlds, cold, silent, and often tinted with colors from frozen chemicals. Though lifeless on the surface, they may still hold secrets beneath. To stand on one would be to see a sky with little light, and a horizon of endless frost. They are reminders that not all planets glow with warmth. Some are places of silence, where time itself seems frozen, waiting in the dark. Rogue planets drift through space without a star. Most planets orbit suns, but not all. Some are set adrift, torn away from their systems, or perhaps never bound to a star at all. These are rogue planets, worlds wandering the galaxy in eternal night. Without a sun to warm them, they may still glow faintly with heat left over from their birth, or be warmed by radioactive elements within. Imagine a world with no sunrise, no sunset, only darkness, with moons or rings circling in silence. Some might even host subsurface oceans hidden beneath thick crusts of ice, warmed only by the planet's core. To float endlessly, carrying oceans, mountains, or storms into the deep dark between stars. That is the fate of a rogue planet. They are cosmic orphans, solitary travelers through the endless night. Some planets orbit two suns at once. In some systems, two stars circle each other like partners in a slow dance. Around them, planets can form, locked into orbits that bring two sunrises and two sunsets each day. These are circumbinary planets, places where the sky glows with two suns. Sometimes the stars are close together, appearing as twin lights in the heavens. Other times, they drift farther apart, creating shifting patterns of warmth and shadow. The landscapes on such a world would change in rhythms we can only imagine, with skies lit by double dawns and long, complex twilights. Though once thought unlikely, astronomers have found real planets in such orbits, proving that the universe is more inventive than we guessed. To imagine standing on one is to feel like a character in a dream, a world warmed by not one, but two guiding stars. The universe may be a hologram. It sounds like science fiction, but some physicists have seriously explored the idea that our three-dimensional universe might be a projection from a deeper, two-dimensional reality. This is known as the holographic principle. It comes from studies of black holes, where information about everything that falls and seems to be encoded on the surface, not the volume of the black hole itself. Some theories suggest that the universe as a whole might work the same way. What we perceive as space and depth could be a kind of mathematical illusion, arising from information encoded on a distant boundary. It's not proven, and probably won't affect your day-to-day life, but it's a gentle reminder that reality, even at its most solid, may not be quite what it seems. Space may be granular at the smallest scale. To the naked eye, space appears smooth. Even under a microscope, it's still empty and continuous. But some theories of quantum gravity suggest that space itself may be made of tiny discrete units, like grains or pixels in a digital image. This smallest possible scale is called the Planck length, about 10 to the minus 35 m. At that level, smoothness may break down into something more fundamental, a grainy, foamy texture of spacetime itself. We don't yet have the tools to see it, or even to test it directly, but if it's true, then everything, stars, galaxies, thoughts, even sleep, happens not in a perfect void, but in a universe with structure all the way down. There are stars that spin faster than kitchen blenders. Some stars rotate so rapidly that their equators bulge outward, and their surfaces blur into a speeding blur. Neutron stars, the dense remnants of massive stars, take this even further. A type called a millisecond pulsar can spin hundreds of times per second. That means the entire star, a city-sized sphere of nuclear matter, rotates faster than a blender blade. These objects emit beams of radiation that sweep across the sky like cosmic lighthouses, ticking with astonishing precision. Many of them are locked in tight orbits with companion stars, pulling in matter and gaining speed. They're some of the fastest known rotators in the universe, and also some of the oldest clocks ticking silently in the night. Gravity can bend light like a lens. In the vastness of space, even light does not always travel in straight lines. Gravity, the same force that holds us to Earth, can bend the path of light as it passes near massive objects. This effect, predicted by Einstein, is called gravitational lensing. When light from a distant galaxy or star passes by something heavy, like a toaster of galaxies or a black hole, its path curves as though it had passed through a giant cosmic lens. To us, the image may appear stretched, doubled, or magnified, revealing details we could not otherwise see. The universe, in this way, helps us look deeper into itself, bending and magnifying its own light. It is a quiet trick of nature, showing that space is not empty, but flexible, and that gravity can shape even the most intangible thing, the light of the stars themselves. Distant galaxies appear multiple times in the sky because of it. Sometimes, when we gaze deep into the universe with our telescopes, we see something curious, the same galaxy appearing in several places at once. This strange vision is caused by gravitational lensing, where the gravity of a massive object bends light around itself like glass bending a reflection. To us, it can make one distant galaxy look like 2, 3, or even 4 separate images, shimmering around the edge of the lensing mass. These cosmic mirages not only dazzle the imagination, but also allow astronomers to study galaxies too faint to otherwise detect, magnified by the bending of space itself. To think that we can see echoes of the same galaxy scattered across the sky is to realize how strange the fabric of reality truly is. The cosmos, through gravity, paints illusions that reveal deeper truths. Time passes differently in strong gravity. Time, which we often think of as steady and constant, can flow at different speeds depending on where you are. In regions of strong gravity, like near a massive planet, star, or black hole, time slows down compared to places with weaker gravity. This is not just theory, it has been measured with delicate instruments, even between clocks on mountaintops and clocks at sea level. In space, near the densest objects, the effect becomes extreme. To an outside observer, everything near a black hole seems to slow, as though caught in a never-ending pause. Yet to the one experiencing it, time feels normal. This bending of time is part of the deep connection between gravity and the fabric of the universe. It reminds us that reality itself is flexible, and that time is not the same everywhere, but is woven into space like a living thread. Astronomers once mistook quasars for nearby stars. When quasars were first discovered, they looked like faint, point-like objects, almost identical to ordinary stars, but their light didn't behave the way it should. Their spectra were strange, and their brightness varied in puzzling ways. It took years to realize that these weren't stars at all. They were distant galaxies with incredibly active centers. A quasar is powered by a supermassive black hole, surrounded by a swirling disk of hot, falling gas. That gas heats up and glows with unbelievable intensity, sometimes outshining the rest of the galaxy combined. The first quasars were so far away that their light had traveled billions of years to reach us, and yet, they looked like tiny stars. A case of mistaken identity that turned out to be one of the brightest discoveries in astronomy. Our local group of galaxies is falling toward a hidden region. The Milky Way doesn't sit still. Along with the Andromeda Galaxy and dozens of smaller companions, it drifts through space as part of a loose collection called the local group. And this group, in turn, is moving towards something larger, a gravitational anomaly called the Great Attractor. But beyond even that, lies a more mysterious region, the Shapley supercluster, and perhaps others still hidden by the dense plane of our galaxy. These distant masses exert a pull we can measure, even though we can't yet see all of them. It is as if our entire neighborhood is sliding towards something enormous wrapped in shadows. We don't know what lies in that direction, only that we are moving toward it, slowly, pulled by the weight of unseen giants. We are living in the universe's stellar springtime. Right now, the universe is filled with stars burning, forming, exploding. But this is a relatively recent development. For the first few 100 million years after the Big Bang, there were no stars at all. The first ones formed in darkness, lit up their surroundings, and began the process of cosmic evolution. Since then, star formation has risen, peaked, and slowly declined. We now live in what might be called a cosmic spring, a time when new stars still form, but less than before, and much more than will come in the far future. One day, the last stars will be born, and after that, the universe will slowly darken. But for now, it is still alight with new beginnings, bright enough to wonder, quiet enough to rest. There are galaxies that shine in radio waves like celestial beacons. Some galaxies do not glow brightly in visible light, but instead shine fiercely in radio waves. These are often powered by supermassive black holes at their centers, driving jets that extend for thousands of light years. Through radio telescopes, they appear as enormous, ghostly structures, far larger than the galaxies themselves. To human eyes, they may look dim, but in radio frequencies, they blaze like beacons. Radio galaxies allow astronomers to trace magnetic fields, energetic particles, and the activity of black holes across cosmic distances. They are reminders that the universe speaks in many voices, from visible light to invisible waves. By tuning into these hidden channels, we hear stories otherwise lost in silence. They are proof that the cosmos is not dark, but full of signals calling out across the void in ways our eyes alone can never see. The universe is filled with invisible neutrinos streaming through us. Every second, trillions of particles called neutrinos pass through your body, through the Earth, and out the other side. They are nearly massless, ghostly travelers that interact so rarely with matter that they slip through planets and stars as though nothing is there. Neutrinos are created in nuclear reactions in the heart of the Sun, in exploding stars, and even in the Big Bang itself. For decades, they were thought to be massless, but now we know they carry the faintest weight, enough to influence the universe's evolution. To detect them requires enormous underground detectors filled with pure water or heavy metals waiting for the rarest of collisions. Yet whether we detect them or not, they are always here, streaming invisibly around us, through us, within us. The universe is not empty. It is alive with ghostly rivers of neutrinos. Cosmic rays from distant explosions strike Earth constantly. From the farthest reaches of the cosmos, high-energy particles race through space at nearly the speed of light. These are cosmic rays, born in supernova, black hole jets, and other violent events. They travel for millions or billions of years before reaching Earth, where they strike our atmosphere in constant showers. Most are harmless, their energy absorbed before they reach the ground, but their presence is a reminder that the universe is always in motion, always sending whispers of distant violence across the void. Sometimes, the highest energy cosmic rays carry more punch than any particle we can create in human laboratories, a staggering force delivered by nature alone. Even as we rest beneath the calm night sky, we are bathed in these ancient travelers, cosmic messengers carrying the story of explosions that happened long before Earth was formed. Distant galaxies glow with light that left them before Earth formed. When you look at a galaxy a few billion light-years away, you're not just seeing distance, you're seeing age. The light from that galaxy began its journey long before Earth existed, before the Sun formed, before our solar system had even begun to take shape. Some of the galaxies we observe today sent out their light over 10 billion years ago. That glow crossed expanding space, stretched and reddened along the way, until it finally reached our telescopes. In a sense, we are watching the universe's ancient past in real time. The stars we see in those galaxies may be long gone. Their light remains, a soft reminder that the night sky holds stories older than Earth itself. Entire galaxies can vanish behind clouds of dust. Even something as massive as a galaxy can be hidden by dust. In some regions of space, thick clouds of interstellar dust obscure the light behind them. This dust isn't like the kind you find on a bookshelf. It's made of tiny grains of carbon and silicates drifting through cold molecular clouds. When a galaxy lies behind one of these clouds, much of its light can be blocked in visible wavelengths. We only see it when we look with special instruments in infrared, radio, or X-ray light, which can slip through the dust more easily. Astronomers have discovered entire galaxies this way, lurking behind what once seemed like empty sky. Even in space, appearances can be deceiving. Darkness doesn't always mean absence. Sometimes, it just means waiting to be seen in the right light. Some galaxies are surrounded by perfect circles of lensed light. Sometimes, the gravity of a galaxy bends the light from something even farther away. If the alignment is just right, this bending creates a phenomenon called an Einstein ring, a perfect circle of distorted light. It's a form of gravitational lensing, where the mass of the foreground galaxy curves spacetime, acting like a lens for background light. Einstein rings are rare but beautiful glowing loops suspended in space, formed not by motion, but by perspective and gravity. The light can come from a distant galaxy, a quasar, or even a supernova. These rings help astronomers measure the mass of galaxies, map dark matter, and study the early universe. They are silent, perfect illusions, natural lenses created by the shape of space itself. Matter and antimatter once battled for balance. In the young universe, energy condensed into particles of matter and their opposites, antimatter. Whenever the two met, they annihilated, leaving behind pure light. For reasons still mysterious, there was a slight imbalance. Just enough matter was left over after the battles to form the stars, galaxies, and planets we see today. Without that tiny excess, the universe would have been filled only with radiation, with no worlds, no atoms, no life. The symmetry of matter and antimatter was nearly perfect. Yet it was the tiniest imperfection that allowed everything we know to exist. Scientists still search for answers to why the balance tipped, but to us, it is enough to know that the cosmos itself arose from this fragile difference, a faint bias toward matter that became mountains, oceans, and our own bodies. Existence is the echo of that ancient battle. The universe glowed like a brilliant fireball in its youth. Hundreds of thousands of years after the Big Bang, the universe was still a searing plasma of particles and light. It glowed everywhere, brilliant and uniform, like an immense fireball without edges. The photons within it scattered endlessly, bouncing from particle to particle, unable to travel far. To an observer then, there would be no stars, no galaxies, only an endless bright fog. Slowly, as the cosmos expanded and cooled, atoms began to form, and the fog lifted. Light could finally move freely, beginning its long journey outward. That ancient glow still exists as the cosmic microwave background, stretched into faint microwaves after billions of years. To remember that the universe was once a glowing sea, is to see it not only as dark and starry, but also as something that once shone everywhere, a cosmic dawn before the first stars were ever born. Galaxies formed from tiny ripples in that early glow. The first structures in the universe began as the faintest ripples in the sea of early light. These tiny variations in density, born from quantum fluctuations, grew slowly over time as gravity pulled matter together. Where the glow was slightly denser, galaxies would eventually form. Where it was emptier, cosmic voids would stretch. In this way, the vast web of galaxies we see today traces back to the smallest of ripples, written into the afterglow of the Big Bang. Astronomers have mapped these patterns with satellites, finding the seeds of everything in delicate variations just a fraction of a degree warmer or cooler. It is humbling to think that the spiral arms of galaxies, the stars overhead, and even our own Milky Way all grew from those first subtle patterns. From whispers in the light, entire universes of form and beauty arose. The vacuum of space has quantum pressure. Even in perfect vacuum, where there are no atoms, no particles, no radiation, there's still energy. Quantum physics tells us that empty space isn't truly empty. Instead, it's filled with tiny restless fluctuations, particles and antiparticles appearing and disappearing, fields shifting slightly, always moving. This activity creates pressure known as vacuum energy. On large scales, this pressure may help explain dark energy, the force driving the universe's accelerating expansion. Unlike other kinds of energy, vacuum energy doesn't dilute as space grows. It stays constant, stretching space faster the more there is of it. It's a strange thought that the more nothing you have, the more something it becomes. The quiet force of empty space may be what drives the cosmos apart. Black holes radiate faint heat over trillions of years. Black holes are famously dark, so dense that nothing, not even light, can escape their gravity. But thanks to physicist Stephen Hawking, we know they aren't completely silent. According to quantum theory, black holes can emit a faint glow called Hawking radiation. It happens at the edge of the event horizon, where virtual particle pairs occasionally result in one particle escaping while the other falls in. The escaping particle becomes real, a tiny bit of energy lost from the black hole. Over incredibly long timescales, this slow leakage can cause the black hole to shrink and eventually evaporate completely. For a black hole the mass of the Sun, that process would take more than a trillion years. It's the quietest kind of ending, not an explosion, but a long, slow fade into nothing. The universe contains more plasma than solid matter. When we think of matter, we usually imagine solids, liquids, and gases. But the most common state of matter in the universe is something else entirely: plasma. Plasma is an ionized gas, a cloud of particles where electrons and nuclei move freely. It's found in stars, in the solar wind, in interstellar space, and even in the vast regions between galaxies. Most of the visible matter in the universe is in this state. Plasma behaves differently from other forms of matter. It responds to magnetic fields, flows like fluid, and can carry electrical currents across enormous distances. On Earth, we rarely see it outside of lightning, fire, or neon lights. But in space, plasma is everywhere, glowing, flowing, and shaping much of what we see, even when we don't realize it. Without supernova, planets like Earth could not exist. The explosion of a supernova is both an ending and a beginning. In its final breath, a massive star scatters the elements it forged across light years, seeding space with carbon, silicon, oxygen, and iron. Without these gifts, there could be no rocky planets, no oceans, no living beings. Earth itself is built from the ashes of stars that lived and died long before. Our very planet is a mosaic of ancient starlight reassembled into continents, mountains, and seas. Every rock, every tree, every heartbeat carries within it the legacy of explosions that tore stars apart. To know this is to understand that destruction in the cosmos is not only loss, but creation. Out of the death of stars comes the possibility of new worlds. Earth is proof. A planet formed from stardust carrying life in the wake of stellar sacrifice. Even now, new stars continue to shape the universe. Though billions of years have passed since the first stars lit the cosmos, the universe is still creating. In vast clouds of gas, stars continue to form, igniting their fires and beginning their long journeys through time. Each newborn star shapes its surroundings, carving bubbles in the gas, sending out winds, and sometimes giving rise to new planets. The process is slow, but unending. A quiet heartbeat of creation woven into the fabric of the universe. In places like the Orion Nebula, we can see this happening even now. Nurseries where countless suns are being born. To realize that the universe is not finished, but still unfolding, is a comfort. Creation is not a single event in the past, but an ongoing story. As you drift to sleep, stars are kindling across the galaxy, adding their light to the eternal sky. Some black holes may be primordial, born in the early universe. Not all black holes may come from dying stars. Some scientists believe that moments after the Big Bang, when the universe was still dense and chaotic, regions of space could have collapsed directly into black holes. These are called primordial black holes, and if they exist, they could range from the size of mountains to objects as heavy as whole planets. Some may have evaporated long ago, while others could still drift unseen, hidden among the stars. They may even account for some of the mysterious dark matter that shapes galaxies. Though we have yet to find them, the idea is haunting that scattered across the cosmos, there may be ancient black holes older than any star, relics from the very first heartbeat of time. Silent, invisible, and mysterious, they would be fossils of the universe itself, holding secrets from its earliest moments. Some black holes launch jets thousands of light years long. At the hearts of galaxies, supermassive black holes sometimes feed on gas and dust spiraling inward. But instead of swallowing it all, they can launch colossal jets of energy outward, stretching for thousands of light years. These jets, made of charged particles traveling near the speed of light, shine brightly in radio waves and can sculpt the very shape of their host galaxies. From Earth, we see them as ghostly streams glowing across the darkness, marking the places where black holes feed. The power involved is beyond comprehension. The energy of entire stars funneled into narrow beams that pierce the cosmos. Yet in their violence, these jets also nurture creation, compressing gas and sparking new bursts of star formation. They are a reminder that black holes are not only destroyers, but also shapers, sculpting galaxies with both gravity and light. Entire galaxies can be stripped of their gas by neighbors. In crowded regions of the universe, galaxies do not always drift peacefully. As they move through clusters filled with hot plasma or pass close to larger companions, their reservoirs of gas can be stripped away. This process, called ram pressure stripping, leaves galaxies barren, unable to form new stars. What remains is a silent collection of aging suns slowly fading. Astronomers sometimes call these quenched galaxies. Star cities cut off from the very fuel that once gave them light. To see them is to glimpse the quiet consequences of cosmic interaction. Beauty turns stillness. Yet even in this stripping, there is motion and balance as gas flows into other regions, feeding new creations elsewhere. Galaxies, like living things, are shaped by their environments, nurtured or diminished by the forces around them. The universe is never static. It is always reshaping itself, sometimes gently, sometimes with great force. There are stars that suddenly blink out and reappear. Most stars shine steadily, their light constant across years and centuries. But some behave strangely, fading away and then returning without warning. Astronomers have observed stars that dim so drastically they seem to vanish, only to brighten again later. Some may be hidden by passing clouds of dust, others by the strange dynamics of collapsing matter. A few may represent events we still cannot fully explain. One famous example, known as Tabby's star, baffled scientists with irregular dips in brightness that seemed too complex for planets alone to cause. These blinking stars remind us that even something as familiar as starlight can hold surprises. They are quiet enigmas shimmering in and out of view like cosmic lanterns behind shifting veils. Each flicker is a question, a reminder that the universe still holds secrets even in the lights we have watched for centuries. Some galaxies are so faint they are almost invisible. Not all galaxies glow brightly. Some are so diffuse, their stars spread thin across vast regions, that they are nearly invisible against the night sky. These ultra-diffuse galaxies can be as large as the Milky Way, yet contain only a fraction of its stars. To see them requires sensitive instruments carefully tuned to pick out faint smudges of light from the darkness. Their existence challenges our understanding of how galaxies form and survive. Some seem to float quietly in space, while others live in crowded clusters, surviving despite their fragile appearance. They remind us that the universe is filled not only with brilliant spirals and dazzling ellipticals, but also with ghostly forms, barely there, delicate and strange. To know they exist is to imagine galaxies like wisps of smoke drifting across the cosmos, almost unseen, yet still part of the grand tapestry of creation. There are galaxies are so dense they contain trillions of stars. Some galaxies are so crowded with stars that they contain trillions within their boundaries. These giant ellipticals are among the largest structures in the universe, glowing with the combined light of countless suns. They are often found at the centers of galaxy clusters, where they dominate their surroundings with their sheer mass. Their light is soft and diffuse, yet immense, like a glowing ball of starlight stretching across space. Within them, stars move in all directions, a chaotic sea without the graceful spirals we see in galaxies like our own. They are cosmic metropolises, star cities on a scale difficult to imagine. To gaze upon one is to see not just a galaxy, but a universe within a universe packed with light and life, a radiant monument to the slow, patient growth of the cosmos over billions of years. Gamma ray bursts can release more energy than the sun will in its lifetime. Among the most powerful events in the universe are gamma-ray bursts, sudden flashes of high-energy radiation that can outshine entire galaxies for moments at a time. They are thought to occur when massive stars collapse into black holes or when neutron stars collide. In seconds, they release more energy than our Sun will in 10 billion years of steady burning. From Earth, they appear as brief bursts lasting only seconds or minutes, but their brilliance travels across billions of light years. Though dangerous up close, they are far enough away that we only catch their echoes, brief whispers of unimaginable violence. They remind us that the universe, while often calm and quiet, also carries moments of staggering intensity. A single burst, unseen by our eyes, but recorded by telescopes, tells of distant destruction, carrying the raw power of stars tearing themselves apart. Magnetars hold the strongest magnetic fields known. Neutron stars are already extreme, but a rare few are stranger still. These are magnetars, stars with magnetic fields trillions of times stronger than Earth's. Their fields are so intense they could strip information from a credit card from thousands of kilometers away. On their surfaces, crusts crack and shift, releasing bursts of X-rays and gamma rays. Though only a few dozen have been found, they are among the most powerful objects in existence. Tiny spheres just a few kilometers wide, yet holding more energy than entire planets. Magnetars are fleeting in cosmic terms, their intense fields fading after tens of thousands of years. Still, during their brief lives, they shape their surroundings in ways we can barely imagine. They are the universe's magnets, strange and fearsome, showing us that even among stars, there are extremes beyond comprehension. Gravitational waves ripple through space from colliding black holes. When black holes or neutron stars collide, they send ripples through the fabric of space itself. These are gravitational waves, first predicted by Einstein and confirmed only recently by detectors on Earth. Like ripples on a pond, they spread outward, carrying information about the cataclysm that created them. For a fraction of a second, the detectors stretch and squeeze by distances smaller than an atom, recording the faintest whispers of cosmic collisions. Each wave tells us about the masses involved, their spins, and their fates. To think that space itself can ripple, and that we can feel those ripples across billions of light years, is astonishing. It is as though the universe has a voice, speaking in vibrations too subtle for us to hear, but strong enough to be measured. Through them, we listen to the deep music of the cosmos. Space itself can stretch and shrink with these ripples. Gravitational waves are not just disturbances moving through space, they are stretches and squeezes of space itself. As a wave passes, distances briefly change, expanding in one direction while contracting in another. Though the effect is incredibly small, it carries the story of some of the universe's most dramatic events. When two black holes spiral together, the waves they send out alter the very fabric of reality. On Earth, these ripples are so faint we would never notice them in daily life. But with sensitive detectors, we can measure the tiniest shifts in length. Each detection is like catching the echo of a collision across unimaginable distances. To imagine space itself stretching and shrinking is to realize that reality is more fluid than solid. The cosmos is not just a stage on which events unfold, it is part of the performance itself. Earth orbits a modest star in a spiral arm of the Milky Way. Our home planet circles a star that is neither the brightest nor the largest, but steady, calm, and long-lived. The Sun is a middle-aged, medium-sized star, resting quietly in one of the Milky Way spiral arms, the Orion Arm, a minor branch compared to the galaxy's grander spirals. From here, we orbit at just the right distance for life to flourish, far from the crowded and dangerous galactic center, yet close enough to see the glow of our neighbors in the night sky. Our position gives us a peaceful vantage point, surrounded by open space, but not too isolated. To think of it is to realize how fortunate Earth is. A small world orbiting a modest star, tucked away in a quiet corner of a galaxy with hundreds of billions of suns. Humble, fragile, and yet just right for us to call home. Our galaxy is part of a small group called the Local Group. The Milky Way is vast, but it is not alone. It belongs to a collection of more than 50 galaxies bound together by gravity, known as the Local Group. Our closest large neighbor is the Andromeda Galaxy, a spiral even bigger than ours, slowly moving toward us in a dance that will one day bring the two together. Scattered around are smaller galaxies, companions like the Magellanic Clouds, visible from the southern hemisphere, or tiny dwarf galaxies orbiting quietly nearby. Together, these galaxies form a kind of family, drifting through the larger cosmos as a unit. Though the Local Group is only a tiny fraction of the universe, it is our immediate neighborhood in the stars. To imagine it is to picture a cluster of glowing islands floating together in the great ocean of space, companions on a shared journey through the dark. That group orbits within the vast Virgo supercluster. Beyond our local group lies something far larger, the Virgo supercluster, a sprawling collection of thousands of galaxies spread across hundreds of millions of light-years. Within it, galaxies are not randomly scattered, but gathered into clusters, each bound by gravity into enormous cosmic cities. The local group is just one tiny suburb in this grand expanse, settling quietly at the edge. At the heart of the Virgo supercluster lies the Virgo cluster itself, a dense swarm of galaxies glowing like a cluster of jewels in the night. To us on Earth, these galaxies appear as faint smudges in the telescope, but in truth, they are entire universes of stars. To know we belong to such a supercluster is to see how connected all things are. Our galaxy is not adrift alone, but part of an immense cosmic structure, a vast community of light. Even that supercluster is only one thread in the cosmic web. As immense as the Virgo supercluster is, it is still only part of something even greater. Across billions of light-years, galaxies and clusters gather into filaments, vast threads of matter forming a structure called the cosmic web. These filaments stretch and weave together, separated by enormous voids almost empty of galaxies. When mapped in 3 dimensions, the universe looks less like a scattered spray of stars, and more like a living network, glowing strands crossing the dark. Our supercluster is only one thread in this cosmic tapestry, connected to others like fibers in a web too large to comprehend. To imagine it is to think of the universe as not only vast, but beautifully organized on the grandest scale. We are part of a web that stretches across all space, a quiet reminder that nothing exists in isolation. Everything is connected. We see galaxies gathered into clusters like pearls on a string. Galaxies rarely exist completely alone. Gravity pulls them together into groups and clusters, bound into great families that can contain hundreds or even thousands of galaxies. When we look deep into space, we often see them strung along in long chains, aligned like pearls on an invisible string. These alignments trace the filaments of the cosmic web, showing the scaffolding of the universe itself. Each galaxy in a cluster carries its own billions of stars, yet together they move in harmony, orbiting their shared center of gravity. Sometimes clusters collide, merging into even larger collections. Other times, they quietly glide in place, glowing gently against the dark. To see galaxies gathered in this way is to glimpse the underlying patterns of creation. The universe arranges itself with an elegance we are only beginning to understand, building structures larger than imagination can hold. The cosmic web stretches across billions of light-years. When astronomers map the positions of galaxies across the sky, a picture emerges. A vast web spanning the observable universe. The cosmic web stretches for billions of light-years, its filaments filled with galaxies and clusters, while enormous voids lie in between. It is the largest structure we know of, a map of how matter has flowed since the dawn of time. Each filament is like a highway of galaxies, drawn together by the gravity of dark matter, glowing faintly in the darkness. From our tiny place inside it, we can only see pieces of this grand design, but computer simulations reveal its breathtaking scale. To imagine the cosmic web is to picture a universe alive with threads of light, woven across unfathomable distances. It is both delicate and immense. A structure is vast that even billions of years of light cannot capture it all. Most of the universe is empty, vast beyond imagination. For all its galaxies, stars, and planets, the universe is mostly empty space. Between galaxies stretch voids so large that a beam of light could travel for hundreds of millions of years without encountering a single star. Even within galaxies, the distances between stars are immense, with more emptiness than matter. Yet this emptiness is not nothing. It is the canvas upon which the cosmos is painted, the stage where the drama of stars and galaxies unfolds. To us, the universe feels crowded with stars, but in truth, they are scattered thinly across incomprehensible distances. This emptiness is what allows galaxies to drift, expand, and evolve. And without it, the universe could not exist as it does. To contemplate such vast silence is to feel both small and comforted. There is so much space, and yet here we are, a quiet spark within it. Yet everywhere we look, we find patterns of structure. Though the universe is mostly empty, it is not random. From the smallest scales to the largest, structure emerges. Stars gather into galaxies. Galaxies gather into clusters. Clusters stretch into filaments of the cosmic web. Even the ripples left in the glow of the Big Bang reveal patterns that seeded all later creation. This order arises naturally from gravity and motion, shaping the universe into a balanced whole. To us, it appears as beauty, spirals, clusters, threads, and voids, patterns repeated across vast scales. Everywhere we look, we find symmetry and rhythm, echoes of creation woven into the fabric of space. To realize this is to see the universe not as chaos, but as a living design. Its structures both grand and delicate. We are part of that pattern, a tiny filament of life woven into the cosmos' endless weave. The universe has no center. It expands everywhere at once. It is tempting to imagine the universe as a balloon expanding outward from a central point. But in reality, there is no center. The expansion happens everywhere at once, like the surface of the balloon itself stretching, with every point moving away from every other. To an observer in any galaxy, the universe would appear to expand around them, with distant galaxies rushing away in all directions. There is no single place where it all began, no edge from which it spreads. Instead, space itself grows, carrying galaxies with it. This can be hard to grasp, yet it is one of the most beautiful truths of cosmology. The universe has no special place, no preferred point. Everywhere is part of the expansion, equally central, equally vast. To live in such a universe is to belong not to a corner, but to everything. Every galaxy is racing away from us in the expansion. When astronomers measure the light from distant galaxies, they find it stretched, shifted toward red, a sign that the galaxies are moving away. The farther a galaxy is, the faster it recedes, carried outward by the expansion of space itself. To us, it seems as though everything is racing away, but to an observer in another galaxy, the same would be true. All galaxies see others rushing outward. This discovery, first made in the early 20th century, revealed that the universe is not static, but dynamic, alive with growth. It means that long after we are gone, the sky will slowly change, with distant galaxies fading beyond sight as expansion carries them away. To know this is to feel both the fleetingness and the grandeur of existence. The universe is always in motion, always growing, a river of galaxies flowing endlessly outward. Some stars are so cool they barely glow red. Not all stars blaze brightly in the sky. Some are so cool and faint that their light is barely visible. These stars, often called red dwarfs, glow with a deep crimson hue, their heat so low they simmer rather than burn. Many are smaller than half the size of the sun. Their light dim and steady, like embers that never quite go out. Though they may be faint, they are the most common stars in the galaxy, numbering in the hundreds of billions. Some live for trillions of years, far longer than the universe has existed so far. Around them, planets may circle quietly, warmed by the faintest glow. These tiny, cool suns are the quiet keepers of the cosmos, enduring when brighter stars fade away, a reminder that sometimes the smallest lights are the ones that last the longest. Others burn so hot they shine blue-white. At the opposite extreme are the hottest stars of all, massive suns that shine in fierce shades of blue-white. Their temperatures can reach tens of thousands of degrees, blazing with energy so intense it bathes their surroundings in ultraviolet light. These stars are short-lived, burning through their fuel in only a few million years. But while they live, they dominate their regions of space. Their light sculpts nearby gas clouds into glowing nebulae, sparking new generations of stars. They are rare, outnumbered by smaller suns, yet their brilliance ensures they stand out in the night sky. To imagine one is to picture a furnace brighter than 1,000 suns, hot enough to melt anything we know, radiating with impossible intensity. Though fleeting, their beauty is unmatched, and their brief lives leave behind legacies of new stars, new elements, and new wonders. Brown dwarfs bridge the gap between planets and stars. There are objects in the universe that are neither fully stars nor fully planets. These are brown dwarfs, often called failed stars. They form like stars, collapsing from clouds of gas, but they never grow massive enough to ignite sustained nuclear fusion in their cores. Instead, they glow faintly with leftover heat, sometimes giving off only a dim red or infrared glow. Some are large enough to resemble small stars, while others are barely bigger than giant planets like Jupiter. They drift quietly through space, often invisible without special telescopes. Though they lack the brilliance of true stars, they are fascinating in their own right, a hidden population between categories, reminding us that the universe does not always follow simple boundaries. To imagine a brown dwarf is to picture a ghostly ember, glowing softly in the dark, neither star nor planet, but something in between. Some white dwarfs will crystallize into cosmic diamonds. When stars like our Sun reach the end of their lives, They shed their outer layers and leave behind dense cores called white dwarfs. These remnants, no larger than Earth, glow faintly as they slowly cool. Over billions of years, their matter may crystallize, forming enormous spheres of carbon and oxygen arranged like a diamond lattice. In time, they will become cosmic gems, stars transformed into giant diamonds drifting in the galaxy. Astronomers believe some white dwarfs we see today are already beginning this process, their cores hardening into crystalline form. To think of such a thing is breathtaking. Stars that once blazed brightly ending not in fire, but in quiet transformation, leaving behind the largest diamonds the universe could ever create. Silent, eternal, and glittering invisibly in the dark, they are reminders of beauty hidden even in stellar death. Others will one day fade into black embers. White dwarfs do not shine forever. After trillions of years as they lose their heat, they will grow colder and dimmer until at last they no longer glow at all. These hypothetical remnants are called black dwarfs, stars that have faded into darkness, embers cooled beyond visibility. None yet exist because the universe is not old enough. Even the oldest white dwarfs still shine faintly, their warmth slowly ebbing. But given enough time, the galaxy will one day be filled with these silent, darkened stars, relics of suns that once gave light and life. It is a haunting vision, a cosmos where the lights go out one by one until only cold embers remain. Yet, it also speaks to the deep patience of the universe. Even stars must rest eventually, fading gently into sleep after eons of shining. Hypergiant stars can shed entire shells of gas. Some of the most massive stars in the universe are unstable giants. Their atmospheres so swollen and turbulent that they shed layers of gas into space. These hypergiants can lose as much mass in a year as our Sun will in its entire lifetime, throwing off shells of glowing material that expand outward like halos. Over thousands of years, these shells form intricate nebulae, glowing in the starlight as cosmic sculptures. The star itself continues burning fiercely, destined for a spectacular end as a supernova. Hypergiants live fast and end violently, but their eruptions help enrich the galaxy with elements that will form future stars and planets. To see one is to witness both beauty and fragility. A colossal star trembling on the edge of collapse, surrounding itself with veils of gas, leaving luminous reminders of its turbulent existence. Collapsing stars can form black holes in seconds. When the most massive stars run out of fuel, their cores collapse under the crushing force of gravity. In just seconds, the matter inside shrinks to an impossibly dense point, creating a black hole. The outer layers of the star explode outward in a supernova, scattering elements across space while the core vanishes behind an event horizon. The speed and violence of this process is staggering. A star that shone for millions of years ending in a collapse that happens almost instantly. To imagine it is to picture an enormous sun folding in on itself, its light extinguished in a heartbeat, leaving behind a shadow in space. These events are rare to witness, but their consequences shape the galaxy, creating black holes that can grow, merge, and influence everything around them. Even in destruction, they are creators, opening doors to new mysteries. Some black holes consume entire stars whole. Every so often, a star wanders too close to a black hole. When it does, the black hole's gravity stretches and pulls it apart in a process called spaghettification. The star is shredded, its gas forming a glowing disk as it spirals inward, heating to millions of degrees before vanishing into the black hole. These violent meals can outshine galaxies for brief periods, as the infilling matter releases enormous energy. From afar, we see them as sudden flares of light, the signatures of stars being devoured. For the black hole, it is simply growth, feeding on what chance has brought too near. Though terrifying in scale, these events are also part of the balance of the cosmos, reminders that nothing is permanent, and that even stars can be undone by the gravity wells lurking silently in the dark. Others quietly sip gas from their surroundings. Not all black holes are dramatic in their feeding. Many grow slowly, drawing in thin streams of gas from their surroundings. As the gas swells inward, it heats and glows faintly, but without the enormous flares of more violent meals. These black holes are quiet, hidden in the dark, revealed only by their subtle effects on nearby stars, or by the faint X-rays of their glowing disks. In some galaxies, countless black holes sip gently on interstellar gas, growing steadily over billions of years. Though less spectacular than star-devouring events, this quiet feeding may be far more common. It paints a picture of the universe not only filled with sudden violence, but also with slow, patient processes unfolding invisibly. These silent black holes remind us that growth takes many forms, sometimes a sudden flare, and sometimes a slow sip across eternity. There may be black holes wandering the galaxy unseen. Most black holes remain hidden without bright disks of gas or dramatic eruptions to reveal them. Some may drift alone through the galaxy, remnants of ancient stars wandering invisibly through space. Astronomers believe there could be millions of these rogue black holes in the Milky Way, passing silently between the stars. We cannot see them directly, but we may detect them when their gravity bends starlight or nudges nearby stars in their paths. To imagine them is to picture shadows roaming the galaxy, unseen and silent, yet present. They are reminders that the universe holds far more than meets the eye. For every brilliant star we see in the sky, there may be countless invisible companions traveling endlessly in the dark. These hidden wanderers remind us that space is filled not only with light, but also with mysteries that quietly drift beyond sight. The cosmos will continue expanding for billions of years. The universe is not still, it stretches slowly, gently, carrying galaxies farther apart with every passing moment. This expansion began with the Big Bang and shows no sign of stopping. For billions of years to come, space will continue to grow, and galaxies will continue to drift. The stars overhead may appear eternal, but the great web of galaxies is always in motion, always spreading wider. Though invisible to our senses, this expansion is constant, a background rhythm of the cosmos itself. To imagine it is to picture all of space breathing outward, forever stretching into the unknown. We live in a universe that is not fixed, but alive with change. Its future already unfolding in the silent pull of dark energy. Even as we rest tonight, the cosmos grows larger, and the distances between galaxies stretch ever farther into infinity. Distant galaxies will drift beyond our sight. As the universe expands, more and more galaxies will slip away. Beyond a certain distance, their light can no longer reach us, carried away faster than the speed of light by the stretching of space itself. In billions of years, the night sky will grow emptier as only the closest galaxies remain visible. Eventually, future observers may see only the stars of the Milky Way and its merged descendants, unaware of the larger universe beyond. The cosmos will appear smaller, not because it has shrunk, but because its light has been carried away. We live in a fortunate time when telescopes can still gloat billions of galaxies across the sky. To imagine them from view is bittersweet, a reminder that the universe is not only vast, but changing, and that the vision we hold today is a fleeting gift of cosmic history. Stars will burn out, leaving darkness. Those stars feel eternal, each has a lifespan. In billions or trillions of years, they will exhaust their fuel and fade. The largest stars will collapse into black holes or neutron stars. Smaller ones, like red dwarfs, will simmer slowly before fading into faint white dwarfs. Over unimaginable stretches of time, the galaxy's stars will go out one by one until only embers remain. The night sky, once alive with light, will darken into silence. Yet, even in this fading, there is beauty. The elements forged in stars will remain, drifting in space, carrying the legacy of light long after it has dimmed. To think of it is to realize that nothing, not even starlight, lasts forever. But like a candle at the end of its flame, the stars will leave behind a memory of brilliance, a story of creation written into every atom. White dwarfs will slowly cool to nothing. When stars like the sun end their lives, they leave behind white dwarfs, small, dense remnants glowing faintly with heat. For billions of years, these stars will shine softly, cooling slowly as their warmth fades. Eventually, after unimaginable spans of time, they will radiate no light at all. These invisible corpses are called black dwarfs, stars that have grown cold, silent, and dark. None exist yet because the universe is still too young. But in the far future, when enough time has passed, the cosmos may be filled with them, quiet embers scattered through the void. They will be reminders of a time when stars once filled the skies, glowing across galaxies. To picture a universe of black dwarfs is to imagine silence, an end not in fire or violence, but in stillness, as light itself slips into memory. Black holes will evaporate over trillions of years. Even black holes, the darkest and most enduring objects we know, will not last forever. Through a process called Hawking radiation, they slowly lose energy, emitting faint particles as they shrink. Over trillions upon trillions of years, even the largest black holes will evaporate, vanishing in a final burst of light. This process is so slow that none have yet begun to fade. But in the far future, long after stars have gone dark, black holes will be the last luminous events in the cosmos. To imagine them evaporating is to picture the universe slowly emptying, its most powerful engines dissolving into nothing. What remains is silence, a cosmos without stars, without galaxies, only faint whispers of energy fading into the dark. It is a reminder that even the most enduring giants of space are not eternal, but subject to time itself. Even protons may one day decay. The matter that makes up our world feels permanent, as though atoms will last forever. Yet some theories suggest that even protons, the building blocks of atoms, may eventually decay. If so, then after unimaginable spans of time, every atom in the universe would slowly dissolve, leaving nothing but radiation behind. This would mean not only stars and galaxies would vanish, but matter itself would fade into energy. No mountains, no oceans, no planets, only a thin mist of particles spread across endless space. Though this idea is not yet certain, it is a haunting vision of impermanence. Even the most solid stone may one day vanish, not in moments, but in ages so long they dwarf the history of the cosmos. To rest beneath the stars is to hold on to the fleeting gift of matter itself, fragile and temporary. The universe may end in a cold, quiet heat death. One possible fate of the cosmos is heat death, a time when all energy is evenly spread and no more work can be done. Stars will fade, black holes will vanish, and even particles may decay, leaving behind only a thin, uniform haze of radiation. In this vision, the universe does not end in fire or collapse, but in silence, an infinite stillness where nothing stirs. Time itself would continue, but with no change, no events, no warmth. It would be a cosmos asleep forever. Though it sounds bleak, it is also strangely peaceful. The ultimate quiet, the final drift into stillness. If this is the end, it will come not with violence, but with calm, after countless trillions of years. The universe, having burned bright for ages, will simply rest, its long story closing in infinite silence. Or collapse back inwards in a big crunch. Another possibility is that the universe, instead of expanding forever, might one day slow, halt, and reverse. In this scenario, gravity overcomes expansion, pulling galaxies back together. The cosmos would shrink, growing hotter and denser, until all matter collapsed into a final singularity, a big crunch. If so, the universe would end as it began, in fire and density, time folding back upon itself. Some versions of this theory suggest it might not be the end at all, but part of a cycle, with each crunch followed by a new bang, a rebirth of creation. Though current evidence suggests expansion will continue, the idea remained powerful, a vision of the universe breathing in and out across eternity. To imagine it is to see not just an ending, but a renewal, a cosmos forever collapsing and blooming like a great cosmic heart. Some theories suggest it may bounce snorts and begin again. In some models of cosmology, the universe does not end at all, but cycles endlessly between expansion and contraction. After reaching its largest size, it may collapse inward, only to rebound in another big bang, beginning again with new stars, new galaxies, and new stories. This is called the Big Bounce. Each cycle may erase the details of the last, yet carry forward some faint imprint, passing echoes of past universes into new ones. If true, the cosmos may have no beginning and no end, only an infinite rhythm pulsing across time like a heartbeat. To imagine such cycles is to see existence not as a straight line, but as a circle, repeating forever, each turn different, but connected. It is a comforting thought that even if our universe fades, another may rise, carrying the story forward into eternity. Others imagine new universes sprouting from ours. Another possibility is that our universe is only one among many. In this view, new universes may sprout from black holes or emerge from quantum fluctuations, each with its own laws of physics and its own unfolding story. Our universe may be just one bubble in a vast cosmic foam with countless others floating unseen beyond. Some may last only moments. Others may grow vast and rich with galaxies. If this is true, then even as our universe evolves, others are being born in silence, each with its own beginning and end. To think of this is to expand imagination beyond even the stars above us. The cosmos may not only be infinite in space, but infinite in possibilities, with every universe a dream within a dream. We may live in just one of countless realities, each drifting quietly in the endless sea. Even black holes can get kicked across the galaxy. When two black holes merge, they do not always settle quietly. The collision can release powerful gravitational waves in one direction, giving the new black hole a kind of kick. This kick can send it hurtling through its galaxy at astonishing speeds, sometimes fast enough to escape entirely. Imagine a black hole millions of times the mass of the Sun drifting alone between galaxies. ejected by the force of its own creation. Astronomers have found evidence of these wandering giants. Their influence revealed by the stars and gas they disturb in passing. To think of black holes, already so mysterious, being flung across the cosmos is both haunting and beautiful. They remind us that even the most massive objects are not fixed in place. The universe is full of motion, full of surprises, even in the shadows where light itself cannot escape. The universe might be older than we thought. Most current estimates place the age of the universe at about 13.8 billion years. This number is based on measurements of the cosmic microwave background and how fast the universe is expanding. But not all methods agree. Some observations of ancient stars and galaxies suggest they may be older than that estimate allows. Others question the assumed rate of expansion or suggest that dark energy may be changing over time. These tensions haven't been resolved, and most astronomers still accept the 13.8 figure. But the questions remain. Could the universe be older? Did we miss something fundamental? It's possible that what we think of as the beginning was just one part of a longer, stranger story. There are thousands of rogue planets drifting through space without stars. Not all planets orbit stars. Some are completely unbound, floating alone through the galaxy without a sun to warm them or light their skies. These rogue planets may have formed normally, then been ejected from their star systems by gravitational chaos. Others might have formed on their own, like failed stars. They're dark, cold, and nearly invisible unless they pass in front of background stars or glow faintly in infrared. Astronomers estimate there may be billions of them in the Milky Way, perhaps even more than the number of stars. Each one is a silent world, adrift in darkness, spinning alone in the vast spaces between. No sunrises, no sunsets, just endless night broken only by distant starlight. The universe may recycle itself through infinite cycles. The standard model of cosmology describes a universe that began with the Big Bang and will continue expanding, possibly forever. But some theories imagine a different story, one where the universe goes through cycles of expansion and collapse. In these models, the universe doesn't end with a cold fade or a final crunch. Instead, it resets. After reaching a certain point, it might bounce, collapsing inward, then rebounding into a new expansion. Each cycle could wipe away the old structures, but preserve subtle traces of what came before. These ideas are speculative, but intriguing. They suggest that the universe may have no true beginning or end, just a rhythm stretched across unimaginable spans of time. One universe giving rise to another, over and over again. The light from a distant star can be twisted by a single planet. We often think of planets as small compared to stars or galaxies, but their gravity still has power. When a planet passes in front of a distant star, it can bend and magnify the starlight through a process called microlensing. For a brief time, the star appears brighter, its light warped by the hidden planet's pull. This effect has allowed astronomers to discover planets far beyond our reach, worlds we could never see directly. To imagine it is to picture a tiny planet, invisible in the vast dark, briefly revealing itself by bending the light of a star billions of years old. It is proof that even the smallest bodies can leave marks on the grand stage of the cosmos. The universe is not only shaped by giants, but also by the quiet pull of unseen companions drifting silently in the dark. The universe once glowed with a brilliant orange light long before stars and galaxies filled the sky. The young universe itself glowed. As it cooled from its hot beginnings, the light it emitted shifted through colors. For a time, the entire cosmos was bathed in a brilliant orange glow, like an eternal sunset stretched across all of space. Slowly, as the universe expanded and cooled further, this light softened into red, then infrared, and finally into the faint microwaves we detect today as the cosmic background radiation. Though invisible to our eyes now, that orange glow was once everywhere, filling the skies of a universe without stars. To picture it is to imagine space itself alight, an infinite horizon glowing with warmth. The stars we see today are only echoes of that first radiance, the universe's original light show fading into memory, but still whispering through the background of the cosmos. Some parts of the universe are cooling slower than others. The universe as a whole cools as it expands, but not all regions do so at the same pace. Some pockets of space remain warmer for longer due to differences in density, energy, or the influence of dark matter and dark energy. This uneven cooling leaves behind variations in the cosmic microwave background, tiny temperature differences that map the seeds of galaxies. Even today, astronomers find regions that appear slightly warmer or colder than expected, puzzling signs that the universe is not perfectly uniform. These subtle differences may hold clues to new physics or even to processes beyond our visible horizon. To imagine it is to see the universe as a patchwork, not seamless, but textured, with quiet variations woven into its fabric. Even in its vast calm, the cosmos carries hints of complexity, patterns still waiting to be fully understood. We've captured the shadow of a black hole. In 2019, the Event Horizon Telescope released the first direct image of a black hole, or rather, of its shadow. The black hole itself can't be seen, but the glowing ring of hot gas swirling around it reveals its presence. This particular black hole lives in the center of a galaxy about 53 million light-years away. The image shows a circular silhouette, the region from which no light escapes, surrounded by a halo of radiation twisted by gravity. It took years of global collaboration, coordinating telescopes around the world to act as a single planet-sized lens. The result was more than a picture. It was a quiet triumph of science, giving us our first glimpse at one of the most mysterious objects in the universe, not through fiction or theory, but through light. You can see a galaxy with your naked eye from your backyard. Most galaxies are so far away that even powerful telescopes reveal only faint smudges. But there's one you can see without any equipment at all, the Andromeda Galaxy. On clear, dark nights in the northern hemisphere, it appears as a soft, hazy oval in the sky, just visible to the eye. It's over 2.5 million light-years away, meaning the light you see began its journey long before humans evolved. Andromeda contains 1 trillion stars, more than double the Milky Way, and it's slowly moving toward us. It's hard to grasp, but you can look up and see an entire galaxy with no telescope, no filter, just the sky, your eyes, and the soft glow of something vast and ancient drifting in the dark. One tiny satellite detected the whisper of a distant black hole collision. In 2015, a small satellite named LIGO detected something extraordinary, a faint ripple in spacetime from more than 1 billion light-years away. It was caused by 2 black holes colliding, sending gravitational waves across the cosmos. These waves are incredibly subtle. When they reach Earth, they stretch and squeeze space by less than the width of a proton. Yet with delicate instruments, we can detect them. LIGO and its sister observatories act like cosmic ears, listening to the universe's deepest rumblings. What they heard was confirmation of a prediction Einstein made a century earlier, that even in the silence of space, massive events can send out waves we can feel. A single chirp from the merger of invisible giants caught by a tiny detector on a quiet corner of a small blue planet. Thank you for spending this time here, drifting through the cosmos with me. We have moved across vast distances, past dying stars and newborn galaxies, listening to quiet echoes from the earliest moments of creation. And somewhere in all of that immensity, in the glow of ancient starlight and the stillness between galaxies, there was you, breathing slowly, thoughts softening, maybe already drifting toward sleep. As you listened, you may have felt moments of awe, or simply let the words wash over you like a gentle tide. Both are the right way to travel here. The universe never hurries, and neither should we. Its story stretches across billions of years, and we are only passing through, one peaceful night at a time. What lingers is not only the facts themselves, but the feeling they leave behind, the quiet recognition that you are part of something vast and beautiful. Every atom in your body carries the history of stars. Every breath connects you to the cosmos that shaped you. You are never separate from the universe. You are always within it, and it is always within you. So as you drift towards sleep, let your thoughts soften like starlight fading at dawn. Picture galaxies turning slowly in the dark. Imagine stars being born in hidden clouds, and ancient light making its long journey across space to find you here. Let your body rest in that calm, where time stretches gently and the weight of the day becomes lighter with each breath. If these quiet explorations have brought you peace or sparked your curiosity in soft, gentle ways, feel free to like and subscribe. It helps others find their way here, too. One sleepy soul at a time. And if you happen to still be awake, you are welcome to join us in the next video, where another journey into wonder is waiting. But for now, there is nothing more you need to do. Close your eyes. Breathe slowly. And let the quiet beauty of the universe carry you into sleep. Good night.